Good morning, everyone. I hope all are doing good. So, welcome to Open Source Software Days conference, and we are here to celebrate the month of open source. As you all know that this month we celebrate open source along with the biggest event happening, Hacktoberfest. So, about myself, this is Rohit from KonfHub Technologies, and we have been organizing so many conferences from the past few months, and this time we are organizing open source software days. So just let me quickly run through uh, what we have for all of you guys. So I'll just put my screen on the stream. So yes, this is open source software days, and today we are going to have the conference, and tomorrow, which is 31st of October, we are going to have workshop. So this is a 2-day conference and workshop. So guys, if you have not registered yet, then you can still do it. The URL is ossdays.confhub.com. So registrations are still open. So what are the benefits of getting registered to an event? So ultimately you will get the access to all the learning resources, and also you'll get to know about the upcoming workshop which is going to happen tomorrow. So guys, you can definitely go and register for the event, and the URL is ossdays.confhub.com. So without wasting any more time, we'll go to the housekeeping slides. So since many of you will be thinking like, where can I get the session after the event? So yeah, we are going to have all these sessions recorded. The links and slides, the recorded sessions, learning resources, everything will be shared to the participants via post-event mailer. So yes, if you have already registered, then you will definitely get the post-event mailer. In that, you'll get all the learning resources, speaker slides, and the videos and everything. So after every session, we are going to have Q&A session. So guys, please post if you have any question in the comment box. So our speakers will try to answer 2 or 3 questions after their session, and rest of the questions will be answered offline by the speakers. So please post your questions in the comment box. Also, the live chat is only meant for technical questions and relevant discussions. So please refrain from any unnecessary messages. But in case if you have any query regarding the session or anything else, then you can directly message in the comment box. And also guys, like most of the details will be already present in the description box. If you go to the description box, then most of the details are already there. Coming for the agenda. Yeah, so most of you will be waiting like, what do we have today? Like what are sessions we have? So first we are going to have our opening session by Ajeet Singh Raina. This session is going to be from 11:10 to 11:45 a.m. IST. After Ajeet, we are going to have Murughan from 11:45 to 12:20 p.m. Then we have Jayesh Ahire from 12:20 to 12:40 p.m. And then we have 12:40 p.m. to 1:10 p.m. Shreya, Prasad, and Nishkarsh Raj. So this is the last session for the forenoon, and soon after that we'll be heading for the lunch break. So the lunch break is from 1:10 to 1:45 p.m. So just after the lunch break, we'll be coming back for our afternoon sessions. So yes, in the afternoon, we'll be starting with our game time, for which most of the participants will be waiting. So we have exciting game for you, uh, which can like bring a chance for you to earn exciting rewards. After the game time, we are going to start with our first forenoon session, afternoon session with Nilesh Gule from 2 p.m. to 2:35 p.m. After that, we have Rajat and Vineela at 2:35 p.m. to 3:10 p.m. Then we have Ashirwad at 3:10 p.m. to 3:45 p.m. And at last, we have Shubhangi from 3:45 p.m. to 4 p.m. So Shubhangi is going to give the last talk for today, and soon after that, we are going to have another round of game time. So guys, if you would have missed winning a position in the first game time, then you can definitely participate for the second game and earn exciting prizes. So after the game time, we are going to have the closing remarks, then the winners announcement for the quiz and the referral contest. So guys, if you like, most of you will already know that we are running a referral contest. So for the details, you can visit the website and refer your friends to join for the conference. So next we have code of conduct. Yeah. So this event is dedicated to providing a friendly and welcoming experience to all attendees regardless of gender, sexual orientation, disability, ethnicity, or religion. All participants are expected to display a positive community spirit by exercising consideration and respect to all that attend. Unacceptable behavior or harassment of event attendees in any form will not be tolerated. So for the detailed code of conduct, you can visit www.confhub.com/codeofconduct.html. So yeah, so as I mentioned earlier about the quiz, so we are going to have top three winners, like top three on the leaderboard as winners, and each will receive rupees 3,000 cash prize. And the game time is from 1:45 to 2 p.m. So guys, don't miss the quiz time. So I would request all of you to join back soon after the lunch break to participate in the quiz. So here's the cool part. Like, we have exciting and so many learning resources for all of you guys. So if you guys go and visit con.me/oss-learn, then you can find all the learning resources, which most of the speakers will be using, and also about the speaker slides and rest of the content. You can find them here directly. Also, what do we have for you? We have Azure Dev Challenge. So this challenge is meant specifically for OSS Days conference. So guys, you can go and visit ossdays.confhub.com/azure, and you can find there are like several learning paths. So if you finish any of the learning paths and share on social media with hashtag OSS Days, then you will receive Microsoft Azure badge, Heroes badge. So yeah, so we would like to see all of you participating in the conference and earn Azure Hero badge. More details can be found here in the URL. Also, to make any conference successful, they needs so much of support and manpower. So definitely for this OSS conference as well, we had so many community partners who helped us and supported us to reach more audience and help us in every way. So we had around 27 community partners. So just naming them all, we had AI&ML group, we have Bangalore CNCF, we have Cloud Native Bangalore, we have Co-Learning Launch, we have Coderplex Community, we have Cyber Spy, we have Spyosci, Quince, then DevScript, then Docker Bangalore, Docker Pune, .NET Bangalore, Elastic Community, Geek Community, GulfScript, Hypertrace Community, India Startup Bangalore, InfoSec Girls, Java Meetup Bangalore, Mozilla India, Open Community, PyLadis Bangalore, PyLadis Chennai, Python Group, Redis Labs, Script Foundation, Soda Foundation, and Technology Cafe Bangalore. Also, guys, we are streaming this event to Edureka's YouTube platform. So we have Edureka as learning and streaming partner for OSS Days conference. Also, we have Microsoft Azure supporting for the conference. So we are really thankful to Micro Azure for sponsoring this event and making this great with the learning resources and other things for the conference. Also, at last, guys, it would be really great to see you guys making posts on social media and sharing your experiences that how you are enjoying the event. So you can make a tweet on social media with hashtag OSS Days and at the red confirm, and we will definitely like and retweet your post. So Thank you all for joining for the conference. And with this, we will start with the conference. Awesome. So after the introductory part for the conference, I will introduce our first speaker for the conference. So just a quick introduction about our first speaker. He's a part of Redis Labs and he is also very active in the community. So he is also a Docker captain. So can you guys just guess who is it? You can definitely comment in the comment box and let us know. Okay, cool. Hello, Ajeet. Hi, Ajeet. Are you able to hear me?
Yep,
How are you doing?
I'm doing good.
Awesome. We are really glad to have you, Ajit, for our conference Open Source Software Days, and hope you are also pretty excited for the conference.
Yeah, thank you.
Awesome. So, Ajit, you are the first speaker for the conference. So, before that, I would request you to give a quick introduction about yourself. And meanwhile, you can also present your screen so that we can put it on the screen.
Yeah, sure. So let me get started with the slide. Can you see my slide
Awesome.
here?
Yes, yes. Yes, Ajit, you are live.
Okay, then I will go ahead with the presentation. So thank you, everyone. Thanks for joining today. I know that there has been a lot of crises related to pandemic, which is right now going on. But despite the fact that we are here to talk about new technology, to learn new things. So thanks to the organizer, the KonfHub, and all those 30 plus, 40 plus, basically 40 plus community partners who have come together and organize such event. So today I am here to talk about a really interesting topic around real-time object detection and analytics using Docker and RedisEdge stack. So let us get started. So a little about myself. I am blogger at Collabnix. Collabnix is my personal website, which has today around 230 plus blogs on Docker, Kubernetes, and cloud. I am a part of a Docker Captains program. Docker Captains are those experts who go ahead, talk about the technology around Docker, Kubernetes, and especially cloud. And I have been Docker Captain since last 4 to 5 years, and I have been writing, conducting, organizing meetups, conferences all across the globe. I'm also part of, I'm a developer relation manager at Redis Labs, and usually I go ahead and build a developer community and help them adopt Redis. I'm also Docker community leader. We have around 10,200 plus community members in Docker meetup community, and I, along with my fellow co-organizers, been organizing events like OSCON, Docker meetup, Docker Pune, and there are other 5 to 6 communities all across India. I'm also part of ARM Innovator. I work very closely with the ARM community team and try to grow the community in terms of blogging, as well as I'm working in one of the robotic platform called Cherrybot, which I am going to talk about maybe in my future, in the future events. I worked in the companies like Dell, VMware, and CGI in the past, and worked in a different role like IT consultant, QA engineer, as well as a principal engineer. Collabnix.com is my website where you can find all those exciting stuff which can help you to get started with Docker as well as know the latest tech and trends. So today agenda looks quite busy here. I have brought a really interesting topic which I started exploring around 3 to 4 months back, and this is all about AI as well as AI database. Uh, this is something which is quite new, and people have been really writing about that. So I I just thought that whatever, based on the learning and experience which I have around it, I will go ahead and talk about it. I'm also going to talk about AI data pipeline, which is really important. There has been a lot of people who have been talking about AI, but you hear very less about AI data pipeline, which is really a kind of fundamentals of AI pipeline itself, right? And then I'm going to talk about the challenges. What are the challenges with the AI serving platform today we have in an open source as well as an enterprise market? Why Redis and Redis AI? We'll see like how Redis as a NoSQL in-memory key value database, how it solves the problem of the inferencing here. And obviously, you can expect Docker always in my talk. So I'm going to show you like how I can go ahead and especially containerize the whole RedisEdge application, which solves the Redis AI inferencing problem altogether. The target audience for this complete presentation would be MLOps, okay? Just like a DevOps, which is basically a collaboration in between the developer and operation, we have MLOps, which is a collaboration between data scientist and basically the operations team. So if you are one of them, definitely you are going to benefit all of it. So let me start with the problem statement. The problem statement is we have been talking a lot about AI. AI is AI, which you talk about, artificial intelligence. It is basically that branch of computer science which basically goes ahead and try to build those systems which behaves, or you build such kind of an intelligence into the system which behave very similar to how we behave today, right? And let me give you some of the examples. Think of it as like if you are a Netflix user, the next time, say you finished watching one of the movie, and the next time when you go ahead and try to browse the movies, it recommends you something saying like, okay, this is like this is a movie which matches around 93% of what you like. That is basically an AI algorithm which goes in the backend. The one other example would be when you are doing a shopping in Amazon, right? When you are buying a product, and the next time when you order the product, it comes with some kind of a recommendation. That's an AI which is running in the backend. Another good example would be more to do with the LinkedIn. So you might have seen like most of the time when you receive a message saying someone says, "Hi, how are you?" And then there is a kind of a recommendation engine which basically does a kind of smart reply recommendation. That is an AI, and it has something to do with the natural NLP, right? Natural language processing. So AI is everywhere. One of the best term to talk about the AI is the ubiquitous. They are like everywhere. But the problem is when we talk about AI in production, and that's the problem. No one is talking about AI in production, and that's where the whole the challenges come into the picture. The hardest part of AI is not AI; it's basically a data, because now you have an enormous volume of data which is coming to the system. And now to accommodate those volume of data, you need a very robust database, right, to go ahead store it. And as I talk through it, when you have like a large accelerated growth of data in terms of volume, in terms of variety, and in terms of velocity, like you need a system which can accommodate it. And why we are talking about that, the reason is because of that there is a kind of a special type of database which has emerged, which is called as the AI database. Now AI database is basically targeted with a purpose of speeding up your machine learning as well as model serving. Now these are two important components in AI. It is basically a combination of ML and DL, right? So we are talking about a machine learning, and we are talking about the model serving, which comes under the deep learning. So how we can go ahead and speed up both of the stuffs, that is where the AI database come into the picture. And when we say data, we should know how to go ahead, how to explore the data, how to analyze it. So one of the problem which you would see when you have a huge amount of data is there are certain types of data. One is a good data and one is a bad data, right? So when we say bad data, it could be some kind of a duplicated data which is coming into the system. And when you have a duplicated data in your database, then most probably whatever the report you produce, right, that might not be accurate. So the reason why we are concerned about the data is, when you look at the data pipeline, which I have in the next in the slide, you will realize that when the data moves from the data ingestion stage to to the AI serving phase, right, you will see that there are a lot of challenges in terms of collecting the data, training the data, segregation the data, and then serving the model itself. AI database is a special type of database which helps you to better wrangle the volume, velocity, and complex data governance, and it meets all those the categories, all those requirements, which helps you to take AI model to the production environment. And definitely with open source, since this talk is more and a whole conference is more about the open source, so whatever I'm going to talk about is related to the open source code, open source tools, open source model training, and the models, right? And when we say open source, it comes with the lower cost, but at the same time it is robust. Now let us spend some time about the AI pipeline. And this is really important, because if you see, there are around 5 stages, starting with the data sources and then ending with the model serving. The problem at each of the step is it is very sensitive to data, and we will see in the consecutive in the subsequent slides. The first and the foremost thing is it is the data ingestion part itself. So you might have a data which is coming from IoT devices, for example, or few of the business processes, right? That data has to be ingested, and this data could be anything in terms of the sensor devices, or it could be anything like based on the fraud detection, right? One example could be, or product recommendation, right? There could be a product catalog, and then you have a product recommendation stage. And once this data which is received, it is basically in the raw format. Now, the raw format data has to be in one or multiple ways. It has to be classified and transformed. And in the diagram which you see, if you look a bit closer here, we are trying to go ahead and classify those data, and then put it in the kind of data preparation stage. In the data preparation is basically the pre-processing of your data. And once the pre-processing data is received, then that has to be trained. And that is where your model training comes into the picture, where you have a deep learning framework which comes into the picture. So in one way, you have an old data, and now that old data, from that old data, you have to create a logic. And that logic will help you in inferencing part, where the machine will learn itself what to do. And that is the reason why you see all those recommendations which you coming in the Netflix. System is intelligent enough to go ahead and respond, which means that whatever you have been doing today, your system or your robotic platform, those robotic platforms are able to understand that, and they are trying to behave in the same way. Now, for each of these stages, we have a characteristic. There are feature requirements. Look at the data sources. It is very sensitive to data variety as well as the volume. Data ingestion is very sensitive to data velocity, because there are a stream of data which is coming into the system. It has to go ahead and accommodate those data. Data preparation stage is very sensitive to data quality, because now when you have a raw data and you have to go ahead and classify them, right? That is where the data preparation phase comes. And then all about the throughput, caching, response time, data access latency are the sensitive things which basically the model training or model serving is inclined to. Now, if you look at the challenges which we see here, there are 4 of the topmost challenge which we face with the existing AI serving platform to take it to the production. The first is a slower end-to-end inferencing, right? Now, if you look at the diagram here, the time taken for collecting and processing the reference data is much more larger than the inferencing part. And that is where the inefficiency of the whole AI pipeline falls into the crisis, right? So where you have a data in terms of time series, key value, stream, columnar, graph, or it could be like a document or RDBMS, right? These are the ways where you collect the data. These are kind of a databases, right? So the time taken for collecting the data is much more than inferencing, and that makes, because inferencing is something where your trained model start to behave, you start to learn how you have taught that particular model, right? The other important factor here is, and inferencing is definitely, it's one of the most challenging stuff which we have today. Even if you see the vendors like Nvidia, they have been coming up with a kind of AI platform like Jetson Nano. It solves the problem, but it doesn't solve like 100% of the problem. The problem of inferencing will still be there, because your data has to stay very closer to where your database is, or say your models are deployed. So right now your models or the inferencing might happen outside the database here. The other important thing when we talk about the production environment is a lack of HA, because now the data is very important. You don't want to lose the data altogether. At one point of time, if it doesn't go ahead and try to collect all the data and produce a result out of it or add a logic to it, it doesn't make sense. The other important fact is there are certain models, there are so many backends which are there. How you go ahead and choose those models? So your platform, it should be the solution which you have been using, especially for the training as well as the inferencing, should be agnostic in nature. It should work in any other platform. If I have a solution which works just on x86 hardware and not working in ARM platform, that doesn't make sense, because edge devices are where you collect all those and you want to do all the inferencing part too, right? And then the complexities today, if you see, even if you go ahead and try to compile a solution against the TensorRT or TensorFlow, it takes around 40 to 50 hours of time, right? So it should not be much complex. It should be easy in order to go ahead and deploy those models. Now, why we are talking about Redis here? Now, Redis is basically an in-memory key value NoSQL database system. In-memory means it works on RAM. Key value is the way how the data structure has been built in way you have a key and the value. And then the next thing is basically a kind of a NoSQL database, which means that your data can be in any other form, in the images, in terms of MP4 videos, or it could be in terms of blobs, storages, objects, and all. And you need to have a database which can store that. So Redis is a database which has all the three capabilities. It is an open source, so you can download it, you can install it on any of the Linux or Windows machine. Two of the really important things we really need to have to talk about is the latency and throughput. Low latency and high throughput is something which is really important, and which you get via Redis. And Redis has a data structure also, right? These are like the all open source data structure which you can go ahead and use. The third point is extensibility. Now, this is where we extend Redis in terms of time series, in terms of artificial intelligence, in terms of JSON, graph, in terms of serverless platform. And these are the modules which we are going to talk about today. When you say so let me go to the next slide here. So RedisAI is basically the extensibility which we are talking about. It is a kind of a Redis modules which is open source today. You can even go ahead and try out as a Docker container. You can see the command here, RedisAI/RedisAI. You just have to pull and you have to run it. RedisAI basically does what it does. It basically a module which provides you a tensor. Now, when you say tensor, it is a generalized format of scalar and vector. So there are certain matrices. And what you can do today is you can load these particular tensors as a data type directly into the Redis. And that can be used with GPU, CPU on any of the platform, along with the backends like PyTorch, TensorFlow, and all. If you so what RedisAI does, it basically turns your Redis into a full-fledged deep learning model execution. Okay, it runs it comes with the promise of saying, like, you can run it even on your Jetson Nano board, or you can run it on your Raspberry Pi, given the condition that it has to use a CPU only. Okay, and then it supports all this data structure which is mentioned, like tensor model and script, as well as ML and backend, ML and DL backends like TensorFlow, PyTorch. So these are the leading backend which every solution is looking out for, because they are meant to take the AI to the production environment. Now, benefits of Redis AI has been more like you have a database, you have an in-memory database system, and your data itself, the tensor itself, live inside a database. So you don't have to have, say, the two separate, two separate entities sitting separate to each other. It is more like you have a deep learning platform itself inside Redis database, so which makes the inferencing quite faster, right? You can deploy new models, you can have 10x performance when you are dealing with it, and it has support for major AI backends. It runs everywhere. So this is really cool, and you should go ahead and try this out. Now let's talk about RedisEdge. When you say RedisEdge, it is basically a combination of Redis modules as well as Redis OSS. OSS is open source software, so we have a Redis open source version in combination with streams. Streams, you can think of it as like more like an Apache Kafka kind of a stuff, where you have a huge amount of data coming in and it will accommodate it, right? And then you have a modules. Think of time series as kind of a like a Prometheus, where you can go ahead and run a kind of a time series database. RedisAI is more like an Amazon recognition service, and Redis is more like a AWS Lambda kind of a stuff. But the whole idea is, in order to go ahead and improve the inferencing, you don't have to really deal with any external entities. These are the modules which can be packaged in the Redis database itself, and you can run it. So basically, it bundles all those Redis stream, open source Redis, and Redis modules. And in one of the demo which I'm going to show you, I will show you, like, with just using one Docker Compose file, how I can build the complete solution with all those different components running as a microservices. And again, look at the footprint, like it is lesser than 5 MB, so it can easily reside in any of the constrained compute environment. It can run over the ARM based platform also. And especially, let's not forget about millions of writes per second, as well as the latency, because Redis claims that it is like we promise around less than 1 millisecond of latency, which matters a lot when we talk about any kind of a database. Now, if you look at the complete operation pipeline, this is how it looks like. So you basically get a kind of, think of it as like you have a Raspberry Pi which is connected to the camera module, or think of it as like a Jetson Nano board which is connected to the camera module. And those streams of data has been, it goes to a kind of, especially Redis stream. So which you see the second box here, that is a Redis stream. And the moment you get a frames, the moment you get a frames, it basically triggers your serverless function here, which is like Redis gears. And then after that, the Redis gears basically triggers, especially the Redis AI is something which is more like an Amazon recognition service, where you can go ahead and recognize the objects, okay? And then it basically stores the tensors, and that is where it recognizes the person as a person, as a bottle as a bottle, right? It identifies the object. And once it collects all those data, it basically stores it in Redis time series, which is very similar to how you see a kind of Prometheus, because that is where your time series database come into the picture, and that gets display on the Grafana. Okay, this is how the whole operation pipeline works. And in the demo, I'm going to show you how to go ahead and implement all of these things. Now, we talked about everything. The only thing which is pending is why Docker containers. And the reason is, if you look at the recent report which has come from 451 research, right? They do the survey around AI and containers. They found that around 94% of AI adopters are planning to use container. The reason being, if you look at the portability, which is like, consists of around 10.4. But more than that, if you see here, the faster time to deployment, and you will see in the demo itself, like how easy it is to go ahead and deploy the containerized solution altogether. And when I say container and containerized solution, today container supports GPU. So even you can use a Docker Compose file to go ahead and leverage the GPU itself, right? And the easier management, resiliency, developer productivity, I think these are the obvious reason Docker is popular for. But the whole idea is when you build a solution on AI, do keep in mind that for a testing purpose and even in the production environment, when you have a sufficient resources, you can still use solutions like Kubeflow or solution like Docker containers to run your AI workloads. Now, to give you a glimpse around it, so this is how the Docker Compose file look like. There are a bunch of services like init, capture, and server. So init is something which it's basically a service which initializes the Redis with RedisAI model, and that is where you see a kind of a Python script which runs as a service. And then capture is one which service which captures the video stream frames from a webcam. So if you have a kind of a Raspberry Pi which is connected to the camera module, you can fetch the frames from that. And we have a web server service which basically serves a rendered image composed of the raw frame and the model detection. So with Docker, you can abstract a lot of things here, and it is just a Docker Compose file which I am going to show you in the demo. Apart from that, if one other thing which recently has been introduced is Redis has we have a Redis data source for Grafana, which means that when you have a Grafana up and running, you can go ahead and search for Redis data source, and you can connect to the Redis database and fetch all this information which you required. So it is more like a kind of a monitoring tool for Redis itself. So this is how you go ahead and install. Basically, Grafana is a service, and you pass on the environmental variables, thing like install plugins, Redis app, and then it should be able to go ahead and use that particular data source. If you want to really use it with the GPUs, and then most probably wherever you specify the init.py, you just have to go ahead and say ---- device, and your Docker Compose or the microservices will pick it up. Okay, so let's go to the demo part here. So let me show you. Let me open the terminal here. Okay, so this is a short demo where I'm going to show you the whole, especially the RedisEdge operation pipeline. So under the Collabnix, you have RedisAI Edge Analytics GitHub repo where I have put all the code. I have cloned the repository at this point of time. Under this, you will see that we have a Docker Compose file. If you want to look the same Docker Compose file which I have pasted on the slide, we have 3 of the services. RedisEdge is basically Redis plus all those AI stream time series and gears modules embedded into it. We have services like capture, server, and init. Prometheus here is optional, but if you are using Redis time series, then you don't need that because already we have Redis data source for Grafana which is available. But I'm just showing an example the way we won't be using Prometheus here, but you can still go ahead and specify that service. For Grafana, with Grafana 7.0, this is a particular support which has come where it integrates it with the Redis data source. So let's go ahead and try to see the Docker. So I'm using my Mac machine, which has very latest beta version of 2010. Which is, again, it is not GA, but at the same time, you can still use the Edge release. So let's go ahead and build this particular RedisEdge components all together. You can see here that it is trying to bring up all the services, most probably, and then this particular service gets started. It is loading. Basically, the Grafana, if you see here, they installed Redis app successfully, which means that your Redis data source has been loaded. It will take some time till the Grafana comes up, but most probably it should be up by now. Let me refresh it. Okay, so you see a Grafana dashboard here. By default, you have, like, just for a demo purpose, I will go ahead and put it as supply as the username and password here. And most probably the Grafana should be up by now. At this point of time, I can go ahead and skip it. So once you go to the dashboard, you will see that video stream analysis. So this is an MP4 file which I have loaded, and it is there is a camera 0 here. So at this point of time, it is a file which I have loaded. That's why it is displaying. But when you have a multiple cameras, you can always go ahead and get it displayed here. On the right hand side, if you see the people count and the total unique, non-unique, right? So those are the things. Since there is one person who is making a video, and there is person, if you see one unique person who has been walking, so that is the reason why you see people count as one, whereas in other non-unique one you see a couple of them. One of the other thing which you can do is you can also look at, if you are really familiar with the Grafana, you can select a time frame and all. Let us look at, I was talking about the Redis data source support from Grafana. So let us search for Redis here. If you go to the add data source and try to search for Redis, you will see here data source which appears here. You can go ahead and try to select this. One other thing which you really need to do is you need to go ahead and even before you can import it, but even before that you have to supply the address here. So let me do it again. I will go to the Redis and then try to find out, try to supply the IP address here. So IP address, if you are running on your Mac machine, that should be, you should provide that, or local host. So this is IP address. Let me go ahead and verify that, opening a new window here. So the IP address is 192.168.1.4. It looks good. And then say save and test. So it identified those data sources. And then by now on the dashboard, you will see the Redis streaming as well as the Redis to appear here. When I click on Redis, it fetches all this information which you require, right? Ops per second, connected clients, network, memory. What is the memory it is consuming here? And then I have very limited resources through Docker Desktop, which I have assigned to it. So we really don't have to worry about it. But if you see here, this is Redis time series stream which is coming in, xat camera 0. So I can go ahead and also see like what kind of data or the streams are coming in. And this is ops per second in another way, where I can go ahead and select the timeline, and it will show me especially the Redis version, as well as I can even go ahead and run the commands. Let me show you that. So we have introduced a kind of a new data source, and this is completely open source and especially free, Redis app. And with this, this is basically a new version of Redis data source which I introduced, where we have a CLI version which is available. Now let me show you. Think of it as like, okay, if I want to run a kind of a CLI and want to get a time series data for a particular timestamp, so let me first install it. So we have a Redis application here, which is plugin for Grafana, where I can build a custom panels altogether, right? So in the future, you might be able to see more and more modules appearing here. Even we could have a plan of using RedisAI or Redis Gates altogether. And if you go to the Redis data source, select this new one, and again, you provide especially the IP address of the Redis database server. So most probably it should be able to get connected, and I should be able to fetch the information. If you see here, the Redis CLI appear here, and the same information which you see. But let's go ahead and try to run some kind of a query right on top of your Grafana dashboard. So this is where you can run the command. So let me go back, and you can run all those. You can see the information about the modules, or especially the database. So this is a Redis server information which you are fetching it. So let me go back and try to fetch a time series kind of a data, right? So okay, let us see if it fetches the info of the module. So info modules will help you in understanding about what are the modules which have been compiled here. So since it has been containerized solution, so it might be something I really need to go ahead and verify this why it is not displaying. But most probably you should be able to see the help window. Say, think of it as like a Redis time series. I have all these commands which I can go ahead and run it, like ts.create, ts.info. So it gives you all the information. ts.info expect especially the timestamp info. So let us go back to video streaming and try to fetch the timestamp altogether. So let me pick up the right one. Let's go to the video stream, and the streaming is going on. At the same time, I can go to the overview, and then let us pick up the camera 0, especially the timestamp. Since Redis is a time key value pair database, so key value database, so I can pick up any of the entries. So let me find out one at this point of time. So let's wait for some time. If I have some kind of a time stamp information here, let me open the view. Okay, let's pick up camera colon 0, something similar to that. Okay, let me inspect that. Maybe this is the way where we can go ahead and get some kind of a data. No, not here. So the whole idea is what we are trying to do is running a query, right? So let me pick up this camera 0 and IFPS in FPS. So, and let me go ahead and put it in CLI and try to query it. So it will fetch me the value for that particular timestamp. Okay, let's put it here. ts.info and then the key, and it fetches the value here. What do you see here? Right, for particular timestamp, it fetches the value. Now this looks good. Okay, so, and I think I'm done with this presentation. I don't know whether we have time, but yes, definitely these are the references which you can go through. You can see this code and Docker Compose file on RedisAI Edge Analytics, especially. There are few of the links which you can, if you are really interested in RedisAI and in contributing for this project, you can visit this, and especially about the modules. You can find it under redislabs.com/modules. And these are the open source, software. So you can go ahead, contribute if you are, among the DevOps or the ML Ops engineer. So I think I am done. Thank you so much.
Awesome. Thank you so much, Ajit, for your session. And there were so many questions going around in the comment box. With that, we can definitely assume how exciting your session was. And but unfortunately, we don't have much time to take your time.
Okay.
So YouTube link with you.
Yeah.
I think there is some internet issue with this, right? Anyway, so Ajit, I'll share the YouTube link with you so that you can go to the comment box and take the questions offline.
Yeah. Yeah. Yeah.
Also, guys, we'll be sharing Ajit's speaker slide deck with all of you so that you can go through. I'm really sorry, Ajit. Like there's some serious internet issue. So thanks a lot, Ajit, for your session. And we hope that we will have you in our future events as well. That was really great of having you for Open Source Software Days.
Thank you. Thank you so much.
Thank you, Ajit. Thank you. So All right, guys, that was Ajeet as our first speaker for the conference. And I'm really sorry there is some internet issue at my side, so there might be some lag from my side. Anyway, without wasting further more time, I'll quickly introduce you our next speaker. So our next speaker is from EY, and you can say he's a DevOps champ, and we have been having him for a lot of conferences in our past. So we'll quickly have him on stage. Hello,
Hello.
Murugan. Hi,
Hey,
how are you
what's up?
doing?
I'm doing
I'm
good.
good. Awesome. You were in the backstage when Ajit was speaking, so I hope you like the session.
Yep.
Awesome. So, Murugan, we have you as the next speaker, and we are really glad to have you again for yet another event for us. So, Murugan, can you give a quick introduction about yourself, and meanwhile, you can share your screen?
Okay, sure. I'll do that.
Awesome.
Let me unplug the other monitor.
Sure.
There you go. Can you see my
Yeah,
screen?
it's good. Yes, yes. You're
Okay,
live,
all right.
Murugan. Awesome.
Okay, can you guys hear me well?
Yes.
Okay, cool. So hey everyone, I'm Murughan Palaniachari, and I'm an assistant director. I work with EY, and I didn't want to prepare slides. Uh, we want to go open source, right? So no slides. Just start of showing outside of the slides. So I've been, working on the industry for more than 13 years now, both on the development and operations. Spending more time on the operations in from past 4 5 years, and I'm in love with Azure DevOps. So it's one of the powerful tool, where you can do end to end things. Start from your requirement gathering till your support, right? End to end you can actually manage with the Azure pipeline. So this is what Azure DevOps. So that's just a quick introduction about me. Otherwise, I'm authoring a book. Okay, so one is on blockchain on AWS. That's I also I love blockchain too. So where you can actually writing about how you can build a blockchain solutions on AWS cloud for the business solutions. And the second book, which I'm actually started to write on, is on the Google Cloud. How do you build serverless containers, running a serverless containers on Google Cloud. So that's the second book which I'm working on now. So for today's agenda, so I want to talk about how Azure DevOps is so powerful that you can actually use it for any language or any platform. So Azure DevOps is actually a online based tool that also has a on-prem as well. So it's online based web based tool where it provides, using Azure DevOps you can actually build end-to-end application, right? So it provides multiple options. Like, one is Azure board. So Azure board is where you actually manage uh, your agile board or a scrum board, you can ban or any of the agile, basically where you how you manage your work. And the second thing is it provides Azure pipeline. So this is what we are looking into for today's session, right? Azure Pipelines is actually a service where it helps you to build the complete CI/CD. So when we talk about CI/CD or a DevOps is nothing but basically the DevOps is a culture, right? How we need to work together so that we can actually go faster to the market, we can get the feedback faster, and it's all a continuous learning, right? But at the same time, we also look for the automation, right? Once as a developer, once I'm done with the development, and from there till pushing it to production, everything should be automated, right? So one of the beautiful sentence, it says, human beings are here to solve the problem, and computers are here to do the repeated task, right? So let's leave the repeated task to the computer. and then we solve the real world problem. So Azure pipeline helps us to automate your building your application, testing your application, provisioning infrastructure for any of the application, and also deploying your application to that environment which you have provisioned. Yeah. So that's what the Azure pipeline is. And Azure repo. So there are a lot of places where you can actually keep your code, right? It can be a GitHub or a Bitbucket, uh, any other thing, right? Similarly, inside Azure DevOps, it provides you option like Azure repo, so where you can actually keep your code, right? In fact, Azure pipeline can integrate with any of the other source control as well, version control as well. And it also has its own that's called Azure repo, and this is a Git based one. It also has a TFS one, but it's now everyone uses Git, and it provides the Azure test plan. This is for your the manual sorry, all the test suites or the test management. And Azure artifact, this is to have your artifacts, like instead of, let's say you are using a npm as your artifact repository, right? And if that is an offline, and then your pipeline might not work, so instead within the Azure DevOps you can have this artifact so that it runs faster. And extensions market, let me show that extensions. So one thing here is using Azure DevOps. It's not only for Azure. Don't misunderstood with the name Azure. Okay. So using Azure DevOps pipeline, you can deploy to any cloud or anywhere. So for example, these are the extensions. There's something like in a Jenkins you'll have a plugins which is similar to this. Now let's say I want to deploy to AWS. I can actually search for a AWS plugin. Right. There is AWS plugins out there. Right. You can have them, and let's say you have something else. So you have the IBM Cloud plugins. So a lot more, right? So, or you, let's say you want to provision infrastructure through Ansible. So there is an Ansible plugin. And you say you want to use a Terraform, and there's a Terraform plugin. So this is your marketplace. This is where you actually go and download all your plugins, right? And this can be even dashboards as well. If, for example, I want to have some dashboards, there are a lot of dashboards. Yeah. So you can use CI/CD dashboards and things like that. So that it provides lot many plugins, marketplaces. All right. This is just a quick overview of the Azure DevOps. Now what we will do now is I'll talk about now the pipeline, right? So when we talk about a pipeline or a CI/CD, so that has two phases. So one is uh, your build pipeline. So that is where your continuous integration pipeline. Okay. So in this continuous integration pipeline, you do things like you build the application and you test the application, and you run the let's say if you're using a Sonar Cube for your code quality, and then you run your Sonar Cube analysis test. And then now the security is so important that we also use check marks or Veracode for any of the security scanning. We do the security scanning step, and then finally we create the artifact. So the artifact is ready for the provisioning, right? So that is called your CI pipeline. So let me just pick any one here. Just go to the resource. So now this is how it looks like. And now to log into this, you need to dev.azure.com. This is where the link is. And once you log into this, and you will create an organization. So organization, inside the organization, you can have many projects. Now OSS Days 1 is one of the project. Now if you want to create another project, you can just say click on the create a project. Now let's say OSS Days. I'm just giving us some name, and you can make it as a private or a public, and you can just create it. So once you create this project, so this is where you can actually have your own agile board, and your own pipeline and your own repo and everything. So this is like a project. Now I'll go to the OSS Days 1 project. So here we can see in the board section, this is where you will see all your agile boards. And I'm interested in the repo, Azure repo. Now, if you see here, and this is one example of a Go application. And So using Azure DevOps, you can actually deploy to any platform or any language. So that's what my intention is. So I'm going to pick up multiple languages and show that. So now this is one sample Go application. You can see that here. This is just a simple website, the Go application. And now we always talk about infrastructure as a code, right? We don't want to log into Azure portal and provision any environment. Instead, we should provision infrastructure through code, right? So this is the ARM template. So this ARM template, provisions a web app, to deploy our application. Now I have the code, everything is there, and this is just the web application, and this is my pipeline. And inside the repo, and we still need to follow all things like you're creating a pull request, your branching policy, and all those things it provides. Now, for example, here I can when I click on the branches, and I can go here and I can give the branching policies, like where I can say if somebody need to make a change, and that should go to review, like minimum review should go minimum. I can set 2 or 3, some numbers we can say, and then we also mention the requester should not be approving it, and all the branching policy you can update it here. And pull request, obviously this is where here you can see all the pull request. So whenever developer is making a change, so he'll have to create a pull request, and then the pull request need to be approved by some the colleagues, and then only then it can actually go to the it can build a pipeline. It can do the next step. Now we are interested in the pipeline. So in the pipeline, we can see this. I have created a CI pipeline. This is your build pipeline, right? Let me just show you what are the steps will be there in any pipeline. So whatever in the old school days, whatever we used to do with the shell or the command prompt, we do it with the UI base, same thing like a Jenkins, right? So what I'm doing here, I'm saying, okay, go pick up my code from Azure repo git, and this is my repo name, and pick up from the master branch, and you can select other branches as well. And like I mentioned, you can also pull from GitHub, a Subversion, Bitbucket, and other Git as well. Now, for this Go application, for me to deploy it, I need to build the application, right? So as a first step, I need to mention, okay, which version I should be using. So this is a task. So adding a task is very simple. We click on the plus button here, and we search for what we need to do. Okay, I need to do a Go, and just say add, and then we come here and we select whatever options we need to be added here. Likewise, I've added these many tasks. As a first task, I'm saying, okay, use the Go version. In the second one, I'm saying go get the details. And third task is to build the Go application. I'm just saying, build. The command is build get test custom. Custom is where you can pass the custom arguments. And once the build is success, I need to archive this file. I'm just using this task called archive file. Once the archive file is done, the next step is I'm copying the ARM template, right? Once we go to the CD, the continuous delivery pipeline, we need to provision the environment before we even deploy, right? So I'm just copying this file into the drop directory, the staging directory. And finally, I'm publishing the artifact. So now the artifact is available for release to be picked up. Now I'll go to the releases. Now in the releases, you can see that it'll show how many releases are here, and then what is the status. And you can see that here, the green tick mark, that shows it's a succeeded. And let me click on edit. So this is where here I'm saying go pick up from the latest version of the previous whatever the CI generated artifact. So once we pick that and we create a stages here, so I'm deploying it to dev environment. So in the dev environment, I'm having 4 tasks, right? So my artifact is ready. For me to deploy the application, first thing is I need to have the environment ready, right? So for that, I use this ARM template task. So here I'll say I need to connect to the subscription here, right? So otherwise, see, Azure DevOps and your Azure cloud is completely 2 different things, right? And we need to establish a connection to that. So that you do it with the service connection. So in the project setting, when you go, and let me just quickly show that. So when you go to project setting, so there's this service connection. So this is where you create a service connection. Now, I want to connect to Azure, right? And I select this Azure Resource Manager, and then say I want to connect through service principals, and I enter the subscription name and detail, and this connection will be created. And whenever I want to deploy to Azure, and I can use this particular service connection. Similarly, so for example, let's say when you're working on a Sonar Cube, right? So you'll have to create a service connection for a Sonar Cube, or let's say if you're working on some other, it provides a lot of other things, right? On a Chef and Docker host, a lot more. So these are the service connections you'll create. Now I have created these service connections. Now my CD pipeline knows that, okay, I need to connect to this particular subscription, Azure subscription. And I'm saying, okay, what is the resource group name, and what is the location and the artifact, and then I'm giving the location of my ARM template file is available. So, and this task will actually provision it. And the second one, I'm saying stop the service. This also creates a web app, right? And I'm deploying the code to the web app, then I'm running it. Now, once this pipeline is ready, we say click release, and it actually creates a release, and we can actually see that. So what happens here is when I click on the release, so usually when we run it, we need somebody to execute our code, right? This is a Go application. All the Go related plugins need to be installed. So what Azure DevOps does is it has a self-hosted Microsoft hosted agents, which is actually running. So those agents will have a inbuilt Go or a Python node, and everything is installed. So every time when we create a new build, it actually creates a fresh virtual machine, and then it starts to install all the dependencies and everything. Now we can see that here it creates a folder called D colon A. A is like an artifact folder. So likewise, it creates multiple folders, and it executes. So this is how the line one by one all the steps executes. Now let me show this thing. Right now, we are people. We might be new to Azure DevOps, and okay, how do I get started? Right? It looks. I know it can do a lot of things, but I'm looking for something easier to option. Right? So what you can do. This is very. I just love this one, and when you log into Azure portal and select search for DevOps starter, right? You search for DevOps starter, and you click this, and here this will actually give us the basic template, basic pipeline and everything for your selected language. Now let's say we just looked at Go. Let me look at maybe Ruby. Yeah. So I say I want to Ruby, and I'm clicking on next, and yeah, Ruby on Rails. Okay, this is a web app container application or Linux web app. I'll keep it Linux web app. Then I need to give the project name. I'm just going to give the same name. Okay, OSS 4. So what it actually does is it creates a new project for us in the in my organization. It will just take like few minutes, less than 5 minutes. You will have everything ready. So I'll show you already which I provisioned now. Now, for example, OSS days 2 is one what I provision. Once you actually provision that, okay. So once you provision, the beauty here is now this is the Python application. So what it does is it takes the sample code, and it uploads into Azure repo. We can see that the code has been uploaded here. Sorry, this is a Node.js application. I'm talking about multiple languages here. And it also created a build pipeline. So now we can see here for the sample application, it creates a build pipeline automatically for us. Yeah, and see this in this is the containerized application, a Node.js application. So what it does is it creates a container registry, it builds an image, and push that image to the container registry, and it installs the Helm chart, and then a lot more, and copy the ARM template and a lot more. And if you go to the releases, we can see that it uses Azure CLI to create the cluster, and then Kubernetes to create the namespace, and obviously to deploy the entire application using the helm. So how this helps is, like, when we're starting new, which we don't know how to use it, so this will create your basic template, and after that we come here, and then we modify the code, or we modify the code, and we modify the pipeline, and basically we customize the pipeline based on our need. So it's that powerful to get started with any language. And not only that, right, it also deploys your application. um, Now it created a application, right? You can actually open that website, and it actually deployed everything to you. Now this is still in a progress. The one which we created now, just now, but this one is which language I chosen? I think Ruby. Yeah, Ruby, right? It has actually created the pipeline, and the build is, if you see here, the build is run. It is green. It's successful, and its release is happening now. And once the release happened, it will also deploy. All right. So this is so powerful. Now, initially, so yeah, so this one, right? This is how it shows when you actually run it. It'll show what are the steps ran, and you can click on the each steps to see the debug information and what happened. When something goes wrong, it'll show in red, and then you can actually read through this what actually went wrong. Now we talk about pipeline as code. Like, basically, we are talking about everything as a code, right? And whatever I showed you, that's like your classic editor way of doing, right? But what we are interested is, sorry, pipeline as code. So let me show this. So pipeline as code is basically where you write everything as a code. Now for the same pipeline, what you saw in the UI, I'll show that in the pipeline as code. So Azure DevOps uses YAML to write a pipeline as code. Now I'll select this. This is my Node.js application. Now what we are doing here is you just create a file called Azure pipeline.yaml, and we are saying, okay, trigger from the master branch. And for me to run this, deploy this application, build and deploy this application, I need a variables, that is Azure subscription, web app name, and environment, and all the values. You can pass the variables here. When you have too many variables, you should use a library, so we can actually create a library group. Now after that, I have two stages here, right? So for that, I enter like a stages here, and this is my first stage is a build stage, and the second stage is my deploy stage. The build stage, I would say, okay, I'm creating a job, and my first job is a build job, and the second, and inside the job, and I'm having the first task where I'm building the npm install, and you can execute any script as well, not only those tasks. And next, I'm archiving the file. Let's say that here now you want to add a sonar cube step. So what you actually do here is you go here, very simple to add, right? This is, I just love this. Now usually when you write all the scripts, right, so you click on the show assistant and look for sonar cube. Now let's say prepare analysis sonar cube, and I select, okay, the sonar cube, I've created the service connection. I select, I give my project keys, let's say sample one code. I need to create this projects in the sonar queue for me to work, and then I just boom enter, and you see this. This is so beautiful. It makes it so handy for you to add any task. And similarly, in the CD pipeline on the deployment task, I come here and I'm saying deployment stages. I had another task called Azure Web App. This again looks similar, like where you look for this Azure, yeah, Azure App Service Deployment task, and you just select the service connection, and you select the app name, and boom, done. So you get the code here. So everything is there. Now again, running the pipeline is this looks same. There's no difference. Just run the pipeline, but while running, you can still mention that this needs to go to pull request, needs to be approved. All those things you can actually manage it. Now I'll show you another pipeline where I have a Java application. Now I have run so many pipelines here, and you can see whenever it fails, it shows in red. And you can see here that this pipeline I'm actually deploying to development environment, then I'm deploying it to QA environment. Now, one thing what we okay, before that, so once we pipeline is run, we can see beautifully, how many unit tests have run, how many failed, what are the environments we have created, lot more things. You can have the plugins, and this gives you a lot more functionality. Now, let's say that I want to put some approval process to deploy to staging environment. For that, what you can do, go to the environment, then I select this particular thing, then I click here, and then I say approval and checks. So here you can configure that, for if anyone want to deploy it, that should require an approval. Without that, I cannot go, because you may have a release manager who should approve it. Then you can check that. Now, for example, here I have the approver. I've added my name as approver. He needs to approve it. Only then it can be deployed. Or another option, another beautiful thing is, before even I'm deploying, I want to invoke some Azure function, because that is triggering something else, right? You can actually do that using Azure invoke function. You can even do invoke a REST API. Some API also you can invoke. You can do a lot more customization here. Now I'll show you how you can actually create a brand new pipeline. Now you click on the new pipeline, and I have my code in my GitHub. And it will show it. You need to authorize it. It'll show what are the applications are available. Then I would say, okay, select this Python code. Then it will give me what it does is it looks at your code, and it understands, okay, looks like your application is about trying to deploy to web app, and I'm giving you these are the options you can select. Maybe I would say, okay, I want to deploy this to Linux web app, to Azure. Now, the moment I select this, and it's going to ask some question like which subscription you want to connect to, and I say, okay, I connect to this subscription. And it's going to ask me to log in. And then I need to create my web app. So, okay, I have created a web app called PyFlask. I click on this, and believe me, I didn't have any pipeline yet, right? And this entire pipeline is being automatically created by Azure DevOps itself. What we are seeing is the same steps, right? Your build stage here, and then your deploy stage here. The deploy stage, we are just deploying this Azure web app, and you're provisioning here, and we're saying which Python version. Then again, we just say save and run. So yeah, so this is it. That's it I have for today. I know, and I'm running out of time. Um, so to conclude, this is actually a very powerful tool. Okay, the Azure DevOps, where you can actually use to deploy to any languages and any frameworks as well. Now here, okay, that's okay. So you can actually run to any environments as well. I just show one example. I don't know, where is that? So basically, you don't need not to use only Windows as your platform. You can run your application even for um, Mac OS, or even for Linux as an agent as well. Yeah, I was able to show this one. So you can run this with a Linux and a Mac and a Windows. These are the platform supports what Azure DevOps provides. So feel free to play with this, and the DevOps Starter is a good way to start with, and where you get to learn a lot. And if you guys want to learn, like about more on this, and there are a lot of learning paths have been created. It's a free learning paths. And for example, if you look for AZ400 learning path Microsoft, I just love this. And if you and this will also help you to get the AZ400 certificate as well. And here we can see that this gives you free courses where you can learn end to end. You'll have to spend more time on this, but then you get to learn everything about DevOps and Azure and Kubernetes and things like that. Entire pipeline can be built. Okay. Rohit, I think I'm good, right? I don't take much time.
That was really great, Murughan. So, and there were so many people asking for the learning resources, like where they can find the learning resources, and at the end, you actually shown them like where they can actually go and find all the learning resources. That was really great.
Yeah. In fact, I actually cleared this exam, like AZ 400, and I've actually completed this particular course, and it's a beautiful course. I really encourage, and since it's a free, and really encourage people to take this.
Yeah. So participants, like you can definitely go through these learning paths and you can complete this and get certified. So this is really very beneficial and helpful for you. So, so Murugan, I think you're done with the session. So let's take one or two questions from the comment box.
Sure.
Awesome then. So yeah,
Can I go here? So that's the private. I need to go to comments.
I'll show you the questions on the screen. So here
Okay.
goes the first question from Prateek.
Mm-hmm. If we have to integrate Sonar Scan within the CI build, how can I achieve? Yeah, that's nice. Okay, that's a good question. So I'll just quickly show you that. Sonar. Okay, .NET Sonar. So you need to do two things, right? And if you're using Sonar Cloud is a cloud-based Sonar service. The Sonar Cloud. So you need to create your what do you say, organization, and you create a new project, like something like, for example, OSS days. You create a new project, and in your pipeline, where is the pipeline? Okay, in the pipeline, let me show you. You had steps like this: prepare a analysis on the Sonar Cube and publish a quality gate. So run the Sonar Cube tasks. So this is how you can run it. And I also showed you in the pipeline as well, right? If you want to run it through as a pipeline, you can even do that as well. Like for example, OSS days. You go to repo, not repo, sorry, pipeline. Let me pick up any pipeline now. I click here, and you go to the task here, and here I'll look for Sonar Cube, and then yeah, and let's say analysis Sonar Cube, and you make sure you select all the configurations and just say yes, and then another Sonar Cube task to run the code analysis. Boom. So it just adds two tasks. So that's how you build the integrate Sonar Cube. I can take one more question, right?
Yes, that was awesome.
Okay.
Like it's just really shown up the path totally. So I'll take the next question from Rahul. So here
Okay.
it is.
Is there any way to export pipeline configured using US YAML? Yes, that's a very beautiful question. Yeah, I'll show you that. So
Awesome.
so what happens is, like for example, we have this pipeline called OSS Days 1, and this pipeline has been created with the old school way, right? Your classic editor way. Now, since we talk about pipeline as a code, what you can actually do, once you create this pipeline, if you want this entire YAML file, and you click here, and then you can look for this view as a YAML. Boom, you just copy and paste it. So you have your entire YAML here ready. And if you want a specific one, you can select the specific one and look for the view YAML, and that will give you a YAML script. Okay, do you have
Awesome.
time for another question? No? Okay, it's already 12:24.
Yeah. Anyway, like Murughan, so we'll be sharing the live URL with you so that you can like hop into that comment section and answer them offline. So, and there are really very good questions coming in the comment box. So I'll definitely encourage you to go to the comment box and answer them.
Awesome. Thanks, Rohit. You rock, man.
Awesome.
Thanks a lot.
Thank you
Thanks a lot
so
for the
much,
invite.
Murughan, for joining us today, and hope to
Yeah,
have you in our future performances as well.
cool.
Awesome.
Awesome, guys. Enjoy
Thank
the day, guys. Bye-bye. Yeah. Bye.
Awesome, guys. So that was Murughan from EY. We hope that you guys really enjoy the session because we every time do. And the way he shows up the code and like he deep dives into the learning paths and everything. So anyway, like we have our next speaker, uh, who is also very active in communities and Uh, his name is Jayesh Ahire. So I'll introduce him to the stage. Hello,
Hey,
Jayesh.
hi, Oit. Hey, hi.
Hi, Jayesh. How are you doing?
I'm doing good. How are you?
I'm doing good. Hope you're enjoying the session of Murughan from the backstage.
Yes. It was really good.
Awesome.
So he has set
So
standards so high, so now I have to kill it.
no, no, no. Like we know you will be like really awesome, and our participants are really excited for the session. So, Videsh, I have your screen already, so I'll just show it on the screen so that you can give a quick introduction about yourself, like what you're doing
Sure.
and what your session is going to be today.
Cool. Yes.
Yeah. So here you go. You are live.
Cool. Thanks for it. So good afternoon, everyone. Today, I will be talking about distributed tracing, which is getting a lot of mind share in last few years. Some people even go ahead and call it foundation of DevOps, new foundation of DevOps. So we will see if it really justifies its fancy new title or not. So I'm Jayesh Ahire. I'm currently working as a founding engineer at Traceable.ai, where we are building a modern AppSec platform based on distributed tracing and machine learning. We also have open sourced our underlying observability platform called Hypertrace. And apart from my day job, I also do some independent AI research around distributed neural computers, and I'm involved in this since past few years. So if you want to chat about my work, collaborate, or discuss on some projects, you can find me on Twitter at Jayesh_Ive1. Cool. So let's go through our agenda for next 20 to 25 minutes. We will see why observability became important and what is it. Then we will discuss around, in particular, about distributed tracing, and then we will see a demo of application instrumented with tracing itself. So let's jump into our first broader point for a day: observability. Uh, so monitoring or traditional APM solutions have been around from quite some time. And as this quote says, that monitoring tells you whether a system is working, but observability lets you ask why it isn't working at any particular point. And this why is very important. So I guess we should first discuss why do we need observability, and then talk about what is it. So there are so many reasons actually behind this, and let's just walk through a thought process which will help us understand the reasons better. So if you see, like most of the tech giants, including companies like Amazon, Netflix, started to build their systems using a monolithic architecture, because back in the time it was much faster to set up a monolith and to get the business moving, and that was important. But over the time, as product matures, or as we say, fat growth happens with the growing systems, the code also gets more and more complicated. So they all face the same problem and looked at microservices as a solution. And one of the biggest benefit of using microservices is that each microservice can be deployed, scaled, and developed separately, and you can even replace and upgrade any part of the system independently. So everyone started adopting and using microservices, and here we are today, like looking at very complex modern microservice-based architectures. So uh, like what were the benefits there were for the older technologies? So some of them were like they were really limited set of well defined failure modes. Like yes, things broke earlier as well, but you would pretty much know what broke at any given point, or you would find it quickly, because a lot of older systems failed in pretty much same three older ways, and they will fail in those ways again and again, and you know that what's the problem behind the whole thing. But as our systems become more and more complex, the possible failure became more abundant, and we created monitoring tools to help us figure out what was going on in the guts of our software. So we kept track of our application performance and monitoring data collection, and time series analytics and all those things. But this process was manageable for a while, and it got quickly out of hand because of, again, complex modern systems. So modern systems, when we talk about them, with everything turning into open source cloud native microservices which are running on a Kubernetes clusters, they are extraordinarily complex. And they are now being developed faster than ever, like between CI, CD, DevOps, agile development, progressive delivery. The software delivery train is also speeding up day by day. So with this complex distributed systems which are being developed at the speed of light, the possible failure modes are also multiplied. So when something fails, it's no longer obvious that what caused it. Like we cannot keep up with this by simply building better applications or doing some magic. So, but again, talking about this, nothing is perfect. Like everything will fail at some point. But the best thing we can do as developers is to make sure that we will know when the software will fail, and it should be easy for us to fix the issue. And when we talk about again this thing that unfortunately many modern developers don't know what their software failure modes are. Like in many cases, there are just too many of those, and sometimes we don't even know what we don't know. Like and then this is basically dangerous because unknowns means you won't put an effort into fixing something or fixing a problem in your system because you don't know that problem is existing in the first place. So again, like standard monitoring, the kind of that happens after the release cannot fix this problem. It can only track the known unknowns or track KPIs, but tracking KPIs is only as useful as the KPIs themselves. Like if they are relevant to the failure, they might be detecting, then they are relevant. Otherwise, they are not of any use. So reporting performance is the only as useful as that reportingly accurately represents the internal state of your system. So your monitoring is only as useful as your system is monitorable, right? So when we talk about this concept of monitorableness in your system, we call it observability. So let's just define observability in a broader way. Like in control theory, observability is defined as a measure of how well internal states of your system can be inferred from the knowledge of that system's external outputs. Simply putting, observability is how well you can understand your complex system just looking at the output. So metrics, events, logs, traces, or as we call them, MELT, are at the core of the observability. But observability is more about like it's a whole lot about more than just the data. And uh, like just consider a process like placing an order on any shopping website or Amazon. It failed due to query timeout. So what characteristic did the queries that timed out at 500 milliseconds share in common? Service origins, browser plugins, or something other than that. So here, what helps us is instrumentation. Instrumentation produces data, and queuing that data answers our basic questions about our system. So telemetry or collection for data from instrumentation is a very important part when it comes to observability, as telemetry is what aids observability. So we have to keep some things in mind, like telemetry data isn't observability itself, and instrumentation code is how we get the telemetry. So to aid the observability use cases, your application needs to be instrumented, and telemetry data will describe your system's internal events. So it basically provides you a view into the same underlying truth as monitoring. So let's talk about okay. So let's talk about what I mean when I say metric, logs, and traces, which will pave a path through to the tracing itself. So first, metrics. Metrics are basically aggregated summary statistics, and they are so valuable because everything from operating system to application generates metrics, and they will at least contain a name, a timestamp, and a field to represent some value. So there are so many resources come ready to help us about themselves. Metrics is an obvious first place to start debugging or start when it comes to monitoring. It's the first place to look at. So, and when we talk about logs, like logs are detailed debugging information emitted by processors. So logs are perhaps the second most important tool in the monitoring toolbox because virtually everything logs information. And like they will log information about what they are doing at any given point. And what's more to that is log tends to give more in-depth information about resources than metrics. So if metrics showed the resources that, log will tell us why it died in the first place. And our focus for today, and like last but not least in the monitoring triangle, is distributed tracing. So it provides us insights into full life cycle, or we call it like traces of a request to a system. Traces allow you to pinpoint failures and performance issues with so many applications interdependencies in your microservice world. So these operations will typically involve hops to the multiple services, and these hops are what we call spans. So traces then add like critical visibility into the end-to-end health of your application, and they are solely focused on the application layer and provide limited visibility into health of your underlying infrastructure, but they are still very helpful when it comes to playing at your application layer. So even if you collect traces, you still need metrics to get the full story of your environment, and APM tools feed trace information into a centralized metric store. So traces provide a nice source of data for app centric view. So, talking about it, like structured data can be transmitted into any of these formats. So each of them have their own importance. And cool. So, like now we know about observability, we know about metrics, logs, and traces. Let's just move to our topic for today. Like we are here for talking about distributed tracing. So let's just move to distributed tracing and talk about what is it. So as I said, like throughout the observability thing, that observability is about understanding how transaction flows to the network and the infrastructure. So in a monolithic app, like suppose a Java application, it is feasible to reason about the state and performance of the transactions. Like a client makes a web request and maybe it's passes to a load balancer, and it goes to your web application or like application server, and some database transaction happens in the backend where like you might query your record, or anyway database record get updated and the response is generated and it gets back to client. So, like we will say that there are hops in the system, but this transaction generally takes place in a linear way. Like when you talk about monolith, it generally takes place in a linear way. Here you can see that client initiates a one request in the network, which goes to load balancer, and from where it goes to like a web application and then database, and then like finally that A3 responds back to client. So it's quite possible to instrument each of the hops and visualize the state of the transaction and its performance to the monolith. But it's different than talking about like complex modern architecture. So modern distributed systems, when we talk about them, they are made up of number of microservices, and they represent a complex entity. So a transaction might pass through one microservice or two microservices, uh, like databases, and they might come back and forth in different microservices. So there might be so many interactions happening around the microservices. So in this kind of scenario, the path is not very simple. The path is complex. Like here, a request gets initiated at A0, and like it goes to it might request some operation from service B, and then B might request some operation from service C, and then service C might request some operation from service A. So it's like it's complicated interaction between all the services. So it's quite possible to instrument each of the hops and visualize the state of the transaction, but like it's more complicated than monolith itself. Like so as I said, the transaction is quite different. We have assumed that our system is located in a single virtual entity here, but in when you talk about real world scenario, that your system might be distributed across the world. Like there might your one microservice might be deployed in a Asia region, and one microservice might be deployed in the US region. So you have to consider latency among those as well. So as I said, when it comes to distributed tracing, it like distributed microservices and systems, it's quite complicated. So what is distributed tracing in the first place? So why distributed tracing we should use here, or how it is helping us here? So tracing basically tracks actions or events inside our applications, recording their timings and collecting the other information around them, nature of the action or event. And to effectively use tracing, we need to instrument our application in the first place, which will generate the data or generate the traces for the actions we want to monitor. Like for instance, if we want to monitor interaction between microservices, we have to instrument our microservices, or then it will generate a HTTP request, and uh, we can see that request passing through all the microservices. We can see those hops and traces. The trace is an entity which wraps this request and records and with the start and end time with other information or context, which we will talk about later. So why do I care about all this? Like, why should you care about all this? So tracing basically reduces time in triage by contextualizing errors and delays. It helps you visualize latency, like time my service took with versus how much time it was waiting for other services. It helps me understand the complex interactions, and it helps me see my architecture and visualize my architecture in a better way with a live dependency diagrams and a bunch of fancy stuff. So how okay, so like if I want to explain this in a very simple words, let's just assume you want to book an Uber. Like in a normal days, you will go from one place to another place. You will travel frequently, and when you go out, you want to book an Uber, and you just open your app. You requested for a ride, and it calls some discovery algorithm. Let's just assume that the discovery algorithm is the first hop in our interaction. So it calls some discovery algorithm. It showed you a bunch of cabs available around you, and then you choose a payment method which called like payment service. So this is your second hop. Then the third one will be like you got paired with some driver, which is like suppose there's a pairing service, so it's a third hop. Then when you are paired with your driver, you both are talking to each other, suppose, and that interaction is happening through calling API or Twilio API for that sort. So then that will be your fourth hop. So even if you consider very basic architecture, we are seeing four different hops, like a one single trace in a four hops in just calling a single write. But it's not that simple. Like there are millions of services behind the whole thing, and like tracing helps us to go through all those services and see which service broke at any given point. So talking about trace, span, and context, like what is it actually? So I will use this diagram. So span is the primary component of a trace, and span represents individual unit of work done in the distributed systems. So spans usually have start time and end time. And first span, the request is called as a root span, and all the subsequent spans we call them the child spans. So a trace constitutes more than one span. Like in our example, we have assumed that A1, A2, A3, they're like B3, and there are multiple hops happening. So they all are spans in a particular trace, and the spans are linked to each other using a trace ID. So this makes it possible to build a view of the complete life cycle of a request as it propagates throughout the system. So again, like talking about distributed context, which is really important here and which is a really good thing to have. So they can have the spans can have user defined annotations in the form of tags, which allows you to like add metadata to the span to provide assistance in understanding where the trace is from. And you can also like attach logs as a key value pair in this, or metrics as a key value pair in this, and you can actually see your logs for the particular trace. So it is really helpful in that case as well. And you can use this trace data to visualize your system. You can use this trace data to visualize latency, your live application flow, which we will see in demo as well. Cool. So this is how the trace for the real world application looks like, and it is calling multiple services, and you can see the latency for the multiple services over here. Cool. So enough talk about the whole stuff. Let's just see everything in a live demo and see how actually tracing will be helpful in debugging your performance issues or your application failure, how it actually looks in a real world. So before just jumping to a demo, I will just talk a bit about Hypertrace, which we'll be using for demo as well. So Hypertrace is a real-time observability platform that helps teams make sense of their production request and trends in their network. So Hypertrace converts distributed trace data into relevant insights for everyone. Like infrastructure teams can identify which services are causing overload. The application teams can understand which requests put their service objectives at risk. Deployment teams can identify which version is causing problem in your system. So Hypertrace basically accepts all the major tracing data formats, which means that if you already have a distributed tracing enabled with Jaeger or Zipkin or OpenCensus Open Tracing API, you can go and try Hypertrace without changing anything. So we created it at Traceable and we open source it now. Community is helping us to build it as a best observability platform out there. So if you want to try out Hypertrace, you can just go to GitHub repo for Hypertrace. You can play around with the code. You can clone it. And if you want to deploy Hypertrace on any of the platform, so basically there's hypertrace.properties file in the repo. You can change the ST environment variable to, maybe if you want to deploy in Azure, you can just change it to Azure. And run this dot slash hypertrace.sh install file, and it will deploy the whole Hypertrace platform on Azure. So you can set your kube context manually, or you can, if you don't, it will select your automatic kube context as well. So if you want to try it out locally, we also have Docker Compose file. You can just run that Docker Compose file and get Hypertrace running locally as well. Cool. So moving forward to our demo, like we will see the demo of online boutique app, which is created by Google Cloud, and it's a perfect application if you want to see tracing. Like this involves a lot of services like recommendation engine, product catalog service, then it has payment service, it has cart service, and it has ad service. It has multiple services. So it's a real world example which you can use for demoing tracing and see the capability of tracing in real world. So we will just place bunch of orders. So it will generate traces, and it will send those traces to, this is using Jaeger. Basically, it will send those traces to Jaeger, and we will visualize those traces in a Hypertrace. So moving forward, okay. So here we are on Hypertrace dashboard. It shows you like latency, calls per unit rate, top assets. You will see top endpoints, and you will see top services. You can adjust your time range as well. So suppose I adjust it to 1 hour, then you will see your like you can go through your top endpoints, which endpoints are being used most, and all that stuff. So application flow, as I said, you can use real-time dependency graph for your system. This is how it looks like. Like front-end service is talking to a bunch of other services, and you can actually see data about each of the service as well, like latency, call rate, error rate, and it identifies services and backends automatically. So you don't have to do anything. It will identify your services and backends automatically. So if you go to any of the service dashboard, this is all any service owner might need. And if you look at the dependency graph, your service is talking to all these endpoints, and you can see them in real time. You can see latency, and you can see all the details for each of the service and endpoint. You can see your top endpoints there, then radar, health radar, and you can see a bunch of metrics as well. So if you go to endpoints, like these are all the endpoints frontend is using. If you click on any of the endpoint, you will see similar dashboard for endpoints as well. You will see metrics for each of the endpoint, and traces for each of the endpoints. So if I click on any of the trace, you can actually see the trace view for that particular trace. And here I can see that the recommendation service is taking quite a lot of time. So maybe I will need to do some optimization over there. And you can actually go to that service and debug it, and like
Sorry
make
to
it
bug
make
you, Jayesh.
okay.
Sorry to bug you, Jayesh. Like
Oh,
I think we
time.
are at a bit of time.
Cool. So I will just wrap it up.
Yeah,
So
yeah.
this was basically like a trace view. The Explorer thing basically gives you a lot of filters, and this helps you slice and dice in your traces. Like you have traces from a bunch of different applications or protocols. You can just filter on your protocol and see HTTP traces only. So this helps you in you can slice and dice your spans as well. So there are a bunch of filters you can use. Custom time ranges there. So this is okay. So this was mostly all about Hypertrace, and yes. So if you want to use Hypertrace or try out Hypertrace, contribute to it. We are open for that. Like you can just go to this Hypertrace organization on a GitHub, and you can choose your favorite service, and you can start contributing to it. We even have Slack community where we talk to people who want to contribute, or we talk to people who want to try out Hypertrace. You can definitely join a Slack community, and we will like to interact with you guys as well. So if you want the slides, you can just scan this QR code and get Google's get the slides. And thanks. So yes, I'm done finally. If you have any questions or if you want to talk about Hypertrace, you can ping me on Twitter at Jayesh_IV1, or this is my email ID, jayesh.iv@traceable.ai. We will surely love to chat with you guys around the use cases you have over here. Oh, I'm just looking at the comments. Rohit, you can come now. I'm just looking at comments. Ashok is saying that he's finding it interesting. So, cool, Ashok, you can just ping me and we can chat more about it.
Yeah, definitely, because there are so many comments coming in between. So what you can do, Jayesh, is like we'll share the live URL with you, and you can hop in and answer the questions offline. And
Cool.
also,
Yes.
so participants, like we have Jayesh slide already updated on the GitHub repo. So we'll be sharing the GitHub repo with all of you so that you can go through the speaker slides in that.
Cool.
All
Thanks, Rohit, and thanks your whole team, like Hari, Ganesh, Akshay, you, everyone, like for organizing this conference. It's really great to be here. Thank you.
Thanks a lot, Jayesh, for joining us for the conference, and we look forward to having you in our future conferences as well. That
Cool.
was really awesome.
Yes. Thanks, man. Have a good
Thank you.
day. Have a good day, guys.
Thank you. All right, guys, that was Jayesh from Traceable. And next we have Shreya and Nishkarsh. So before that, I'll just quickly show you the learning resources we have and also what we have next tomorrow. So just let me quickly show you. I hope you guys are able to see my screen. So yeah, so guys, if you haven't registered for the event, then I would request all of you to do that, because only if you are a registered participant, then only you will be getting the notification for tomorrow's workshop. So what do we have for tomorrow's workshop? So yeah, so we have two amazing workshop sessions by Vivek and Karan, and the sessions are Kubernetes 101 by Vivek Sridhar and CI/CD with GitHub Actions and Kubernetes by Karan from GitHub. So yeah, guys, you can go and register for the event, and we'll be sharing the live URL with you for tomorrow's workshop session. Apart from that, we are also running an amazing challenge for all of you, and the name of the session, the challenge is Azure Dev Challenge. So all you need to do is go to this challenge and take any of the learning paths and complete it. And after that, then just share your learning badge on social media with hashtag OSS days. So guys, here is the challenge mentioned on the website. So you can find all the details on the website itself. And since so many people were asking for the learning resources, so guys, we have bunch of learning resources for all of you. So you can directly go and get started with any of the learning resources. These are very beneficial, and we have handpicked them. So yeah, so that was it. You can go ahead and register for the workshop tomorrow. So with this, I won't take much of the time. So next we have Nishkarsh and Shreya. I'll quickly introduce on them on the stage. Hello Shreya, hello Nishkarsh.
Hi, Rohit.
Hey,
How you
how are
guys
you
doing?
doing?
I'm
We are
doing good.
fine.
We are good.
Awesome. Actually before you, we had three sessions from the morning, and yeah, there is some bit of like hodgepodge with the session slots, and We are really apologize for the delay in the session, but no worries, we have you. And yeah, so you guys can introduce about yourself, like what you guys are doing and what your session is going to be today about.
Okay, awesome. So first I'm going to start with my introduction. That's okay, Nishkarsh?
Yeah, sure.
Okay, hi everyone. So my name is Shreya Prasad and I'm a final year CSE undergrad from Indira Gandhi Delhi Technical University for Women. I'm also currently interning as a JavaScript developer at Steam Labs, and I'm also a GitHub campus expert along with Microsoft Learn student ambassador, uh, student ambassador, and I'm also a mentor at MLH, and I've also participated as a Google Coding mentor last year. So I think that's it for my introduction. So you can go on, Nishkarsh.
Sure. So my name is Nishkarsh Raj. I am pursuing my bachelor's. I'm in the final year at University of Petroleum and Energy Studies, Dehradun. And apart from that, I am working as a principal DevOps evangelist at Status Neo. And I am very active in the open source community, where I have performed the 100 days and 300 days of code challenge on GitHub. And I have a current active streak of over 450 days working daily on GitHub. So yeah, that's about it for my side. And let's get in with the session. Shreya, can you please
Sure.
share the slides?
Yes. Can you see them?
Yes, it is.
Okay, so today the topic of our session is full stack DevOps pipeline with GitHub Actions and Azure Cloud. So our session is divided into two parts, where I will be handling the merge stack part and Nishkarsh will be handling the DevOps part. So firstly, we will introduce to the merge stack, and we will help you create a merge stack exercise tracker using MongoDB, Node.js, Express, and React. And then Nishkarsh can guide you further.
Yes, so once we have created an application on our local workstation, DevOps is all about collaboration and automation. So we will host this application live on GitHub and an open source repository so that others can collaborate on it. And then we will configure GitHub Actions, which is GitHub's own CI/CD tool that is continuous integration and continuous deployment, and also configure Docker, which is a cross-platform tool for sharing images that can be run anywhere. And then we will use Terraform for infrastructure automation on Azure Cloud and deploy our Node.js application on a web app using GitHub Actions.
Awesome. So now we will get started with Murn Stack. So what is Murn Stack? So Murn Stack is a set of technologies that are used to create modern single-page applications, and it consists of four main technologies. That is MongoDB, React.js, Express.js, and Node.js. So MongoDB is a document-based open source database, and React.js is a JavaScript front-end library for building front-end for building user interfaces. And then we have Express.js, which is a web application framework for Node.js. And finally, we have Node.js, which is a JavaScript runtime environment that executes JavaScript code outside the browser, like server. Because when JavaScript was created initially, it could be we cannot execute JavaScript in the backend. Like we cannot run it in an environment apart from browser. So that's why Node.js was created, and that's why we use it in Murn Stack as well. So moving on, first we will start with setting up our backend, that is the MongoDB. So for setting up our MongoDB account, first we'll have to create an account on MongoDB at this URL that is present on the slide. And after creating an account, we will get a green button here, as you can see, this new project button. So we have to create a new project, and then we'll be redirected to this create a cluster. So once you have created your cluster, you will have to choose your cloud provider. So here, as you can see, there are three options available to you. You have AWS, you have Google Cloud, you have Azure, and they also provide you free tiers so that you can try out any of the clusters in your personal projects. So as you can see, we can choose any of the tiers and cloud provider along with the regions that are available to us. And once we have selected that, we can create a cluster by clicking on this green button. Then next step is configuring security. So here we don't have to worry about too much details. Here, whenever we are trying to connect our MongoDB account to our project, what we have to do is we have to whitelist our connection IP address. So basically what you have to do is you have to always click on add your current IP address, because since this is a personal project and you are not going to have a large user base, so that is why we always click on add your current IP address. And then you will have to create a MongoDB user. So this will be a user who will be in charge of the cluster that you are creating right now. So by that, we will create a MongoDB user. And then we will have to retrieve the connection information. So there are three ways by which we can connect our application to MongoDB. Either we can use the Mongo shell, that is a command line interface that is provided by MongoDB, or we can connect our application using a connection string, which is the most commonly used method by which we connect our projects to MongoDB. Then finally, we have MongoDB Compass. So MongoDB Compass is a graphical user interface tool that we can use to, visually just go with MongoDB and use it. So once we have decided that we are going to use the second option, we will go to we will see this connect to cluster option, the second part, where we will have to add the connection string into our application code. So, so for doing that, we have to just copy the link that is available. So you can do that by clicking on this button here. So yeah, so now that we have created an account on MongoDB, now it's time to set up our main code. So initial setup. So for initially we need MongoDB in our system, right? So you can install MongoDB from this link, and then you can verify the installation by typing node -- version or node -- v in the terminal. So by that you will get the node version if the node is if Node.js is present in your system. If not, then you can go to this link and install Node.js again. So once we have installed Node.js, we need to create an initial React project using the following command. So npx create React app Murn exercise tracker. So what it is doing is it is creating an initial React project which has a name called Murn exercise tracker. So when we have created a React project with this name, we will go to this directory and then we will type npm start. So what this command is going to do is essentially it is going to start the server of the front end. So when you will type npm start, you will be able to see the front end of the project that you have created till now in your browser by typing localhost 3000. So now that we have created our initial React project, what we have to do is we have to now build our backend, right? So for doing that, we'll go to our root folder, that is the Murn exercise tracker folder, and then we will create a new folder and then change into the folder by running the following commands in the terminal. So I'm sure you folks are familiar with these commands, right? So mkdir is used for creating a new folder. Cd is used for changing directory. So this is the folder that we have created. We have created a folder named Backend. Then we are changing our directory so that we can enter Backend directory. Then we are creating a package.json. So package.json basically stores all the dependencies and all the information that it needs to run the Node.js application. So we are going to create a package.json application. So using npm init-y, we are going to do that. Then we are also going to install some packages. So we are going to install Express, Course, MongoDB, and not MongoDB, Mongoose, and .env. So what are these packages? So we have already discussed Express, right? So Express is a fast and lightweight web framework for Node.js. But what is Course? So CORS stands for Cross-Origin Resource Sharing. And this package allows AJAX requests to skip the same origin policy and access resources from remote hosts. So basically what happens is that your application might be in some, let's say in one origin, and the resources that your application is trying to access is in some other origin, right? So normally what happens is that if you're not going to use this package, your application won't be able to access those resources because they're not in the same origin. So to access those resources that are present in different origins, we use CORS. So the CORS package provides an express middleware that can be used to enable CORS with different options. Then we have already discussed Mongoose, right? So Mongoose, it's a schema-based solution for building application data. So it is a package that makes interacting with MongoDB through Node.js easy for us. Then we have .env. So why are we using .env? So .env loads environment variables from a .env file into a process.env. This makes development simpler, and instead of setting environment variables on our development machine, they can be stored in a file. So that is why we use .env, and we will create this file later on. So finally, we will install one package globally, and that is NodeMon. So NodeMon makes development easier because it is a tool that helps to develop Node.js-based applications by automatically restarting the Node.js application when the file changes in the directory are detected. So there's that for the packages. Next, we have backend server. So this is a simple like Node.js backend server that we have created. We have required these two packages, that is Express and CORS. Then we have required .env so that we can use the data that is present in the .env file into our server. Then we have created an instance of Express and stored it in consta. Then we have also created a port, and we are using 5000 as our port. Then app.use CORS and app.use express.json are basically middlewares. So we are going to use these middlewares because we are going to send and receive data in JSON format. So that so that's it for the middlewares. And app.listen will listen to the port that we are using here. So without this last line, we won't be able to start our server. So this is a really important line. And then we can start our server with NodeMon server. So NodeMon will constantly keep track of the changes that are made in the Node.js file, so that whenever some changes are being made, it will start the server automatically. So next thing we have is connect our database in MongoDB Atlas. So at the top of server.js, after the line const CORS is equal to require CORS, add the following line to require Mongoose. So since we have also installed Mongoose earlier, so we have to require that in our file as well. So we are going to require Mongoose, and after we have included middlewares in our file, we have to add this code. So this is what is this code is doing. It's doing nothing. It's just importing the connection string that we copied earlier, and it is including that here, and it is trying to create a connection with MongoDB using that. And these two variables that we have set to true are you don't need to worry about that very much, and just remember that you have to always enable them as true, because due to some latest versions in MongoDB, we have to do this. So don't worry about why you have to do this. Just you have to do this whenever you're trying to connect to our database in MongoDB. Next, we have how to make connection work. So like I told you before, we have to go to connect. We have to go connect to your application, and then we have to retrieve the string that MongoDB is giving to us. So after that, we will copy that and we will add this to our .env file. So this is the env, this is the connection string that you can see here. And you have to replace this password with the password that you used to set up your user. So if you remember previously, you created, you performed 2 steps in the security section. You whitelisted your IP address and you also created a user for your cluster. So the password that you used at that time will be used here as well. So that's how you replace, that's the password that you use here. So once the connection is established, you will see this message in your console that MongoDB database connection is established successfully. Then now that we have established a connection to our database successfully, now the next step will be to create a database schema. Since we are creating an exercise tracker, so we are going to have 2 entities, exercises and users. So inside the backend folder, we are going to create a new folder again, named models. And inside that model, we are going to create 2 files, namely exercise.model.js and user.model.js. So if you're not sure, if you're not familiar with the term schema, I suggest that you Google up right now so that you can understand what is going on here, because it is pretty simple. And what is happening is nothing. We are just requiring the package mongoose into our file, and then we are creating a schema in which we are creating different fields, and each field has some validations. So like when I'm entering a new user, I want whenever I want that the input of a user should be a string, and that it should be mandatory, and that it should be unique, and that it should not contain any white spaces, and that the minimum length of the username should be 3. So these are some of the checkpoints that we add to validate the input that is being added into our database. So, and timestamp is a default field that is added in every schema to keep track of when that entry was added in our database. So this is how a schema is created, and then we are basically just storing the model in this variable, and we are exporting this. So similarly for exercise or model.js, so size is another entity. So we want the username. So in username, the type should be a string. That means whatever name that we are, like, let's say in place of exercise, I want to write, let's say, walking. So walking is a word of type string, right? And it is required. Like if you are adding exercise in your database, it is required to be like that field should be present. And then we have the description, like what's the description of the exercise that you are performing. So there's that, and then the duration, and then the date.
Shreya,
So these are some.
Shreya, sorry to interrupt
Yes.
you, but we are short on time. Can you please make it fast?
Okay, my bad.
Sure, please
Okay.
tell me.
Okay, so now that we have understood what the schema is, let's go to server API endpoints. So inside the backend folder, we are going to create a new folder named roots. And inside that folder, we are going to create 2 files named exercises.js and users.js. So before writing any code into these 2 files that we have just created, we are going to go to server.js right before the line of app.listen, and we are going to include this code. And why we are going to do that is because we are going to include the 2 roots that we have created into our main server code, so that we can access these roots when the user is trying to go to them. So the first 2 lines are just loading the files, and the 4th and 5th line, they are the middlewares that we are going to use. Next, we have users.js. So since this is a root for users.js, So, but the default, since the default endpoint is a slash, so when the user will get here and perform a GET request, so they will find all the users that are registered in the database. And if they don't find that, then the status will be error. So that's for the GET request. And then when the endpoint is /add, and at that time the HTTP method will be the post request. So at that time, we are going to retrieve the information that is being added by the user into our database. And if we don't get a user, we will send an error request. So there's that. Then similarly, we are going to do for exercises.js. So in this, we are again going to have our default /endpoint in which we are going to find our exercises. So this find function works on promise. So it is going to send me a promise. If my exercises are found, then it will send me the JSON containing the names of the exercises. Otherwise, it will send me an error message in JSON format. Then we have now that we have covered GET request, we are going to have a POST request with the endpoint as /add, where we are going to add the details of the exercises that are being provided by the user into our database. And yeah, so there is that for exercises. So now that we have created our API endpoints, you can test these APIs into Postman. So Postman is a collaborative development software for testing your APIs. So I'm sure you all are familiar with Postman. You can do that. So now that we have created our API endpoints, we will add this code after the routes that we have created in exercise.js. So these are some of the additional routes that we have created in exercises.js. So this is again a GET request. So it is going to find an exercise by ID. So so it is going to find an exercise by ID, and then it is going to return to us that in JSON format. And this one is for delete. So it is going to find an exercise by ID and it is going to delete that exercise. Then this is for post. So it is going to retrieve the information that is being given by the user into our database and store it into our database. So that this is for post part. And next, now the backend is complete and now it is time to start for the front end. So for front end, we are going to use React. So you remember that we've created our initial React project, right? So you can make sure that the front-end development web server is running. If it is not, you can start it with the following command in the terminal. So you can use npm start to see if the server is running. And if it is running, then very well, you can continue and you can install Bootstrap through npm, because that's what we will be using to create our front end. And we can if you go to the initial React project, you can see that there is a file named as app.js. So you can get rid of most of the default code, and all we need is this part. And you also, if you notice here, I have also included this Bootstrap part here. This is because we'll be using Bootstrap into our code. So let's set up React Router. So React Router is again a package that is used to set up navigation paths for different components. So now we are going to install this using npm, and then we are going to embed the JSX code in the router element. So I want to highlight one thing here, like inside the router code. So this div might look like it is an HTML element, but in reality, it is not an HTML element. It is a JSX element, and this JSX is converted into a React.create element in the backend. So no, this is not a HTML, but this is a JSX code. So this is how your app.js should look like when you are embedding this code. So inside the router element, we will add the router configuration. So we will replace the hello world that we saw here previously with this code. So what is happening here is, first we have included this navbar component. So this is a component that has been created, that we will create in the future, and then we have all these roots present here. So what is happening is that this is a path URL, and when the user goes to this path URL, they are going to see this component shown up in their home, in their screen. So that's what it is happening here. So now that we have added all the roots, now we are going to see the full code of app.js after the imports are added. So earlier what we saw was that these components are being shown on the screen after when the user goes to a particular URL, right? But how does React know that where this component is present, or what this component is? So for that, we'll have to import the path, and then we have to give these paths a alias or a like alternative name. So that's what we have done in these lines here. Then in the same directory as app.js, create a new directory called components, and inside that directory, create a file called navbar.component.js, and this is the code for that file. So this, as you can see, this is a simple bootstrap code that has been taken from the documentation website, and this is going to create a navbar in your homepage.
Shreya?
Yeah.
Sorry to interrupt again, but we have to break for lunch after 10 minutes, so that can you please wrap up your session and I can continue?
Okay. So since we are short on time, so we are going to just briefly go through the codes and these components. So these are some of the components that we have created, that is exercise.list, edit exercise.component. So these are some different components that we are using in our web page, since React supports a single page application. So these are the code that you can see on Bootstrap as well. So till now we have done nothing fancy. We are just checking to make sure that these components are working. And this is the whole React create exercise component. So I'm just going to quickly go through the code. So this dot state in here we are just like giving an initial state to each of the data that we are retrieving from the user. So initially the username will be blank, description will be blank, duration will be 0, date will be empty object, and users will be blank. So this is what we are doing here. Then we are going to change, like this code deals with how we are going to update the information that is being sent by the user. And then this code deals with how the submission will work. So on submit, like what is going to happen here? So finally, what is going to happen is that we are going to console.log the final exercise data that is going to come to us. So till now, we have not connected this code to the backend, like to the MongoDB. So we are going to see all of that in console.log. And this is the code that you are going to, this is basically the component that you're going to see on your web page. This one as well. And as you might have noticed that we are using something known as date picker earlier. So since we have not installed that yet, so we are going to install that using npm and using this command. So now you can test out your app that you've made so far. And if you add an exercise, you will see it logged onto the console, like I told earlier. So now that we've created our backend and frontend separately, it's time to connect them together. So how we are going to connect them? We are going to connect them using Axios. So Axios is a library, HTTP library that is used to send requests. So what we are doing is we have done nothing. We have just added this line to on submit code. Basically what we are doing this, we are adding HTTP methods, and then we are adding endpoints. So and we are just performing some, like we are loading some code on that particular endpoint. So that is all that we are adding in our create user file. Yeah, so this is the create user file. So as you can see here, this is the render code, and you can now you can test out your application. So when you will go to localhost .3000/user and you will create a user, you will see that this is the user that we are getting in our MongoDB. So you can check out the input that is being inputted by the user into collection in this collections tab. And then we can also create a new exercise log, like it's been done here. And yeah, and that you can see that also in the MongoDB database. So now this we have done the same with edit exercise code as well. So here we have also added the Axios code, which is basically dealing with HTTP methods. This is like the get method and the endpoint URL, and then what is going to happen if we access that URL. So that's all that's happening here. This is the get request. This is also get request, and this is going to change the state of each detail when the user is adding the code, adding the details. Yeah. So this is a post request, and on submission, this is going to change the state of each data. And this is the code that is going to show on your page. So the edit exercise log page that you saw previously, this is the code for that. So yeah, so we are done. We have now fully created a fully functioning MERN exercise tracker app using MongoDB Atlas. And now I will hand over the presentation to Nishkarsh, and I'm so sorry for taking up so much time.
No, that was great, Shreya. So now that we have created one application locally, we have to set it up for collaboration. For that, we have to push it on any open source repository. And there are different tools available for that, like GitHub, GitLab, etc. We are going to focus on GitHub. So this is our organization status neo. I'm going to create a new repository and name it as KonfHub. And it's a public repository right now, and links are in reference, so you can visit it anytime. And important point of open source repository is that you should always assign a valid license to it. So for that, I have used MIT license right now. There are different licenses like GPL or Apache. You can check out about it. And then on the landing page, I would see that there's only one file called license file on it right now. So we have a GitHub repository on the cloud, and we have our files locally. We have to push them from local workstation to the cloud. For that, we have to follow these commands, and we would see them one by one. So on my Linux machine, I typed in a command ls, which would show me the list of files on my current directory. And then I typed in git init. It would initialize my current local directory as a Git repository. And if I type in ls-a, it would list all the files, including the hidden files. And I would see a .git folder is created, which means it's a Git folder right now. Then we have to run some configurations. So these configurations are only to be made when you are using the Git bash locally for the first time. And the commands for that are git config ---- global. You can configure your username and email by that. This must be the same username and email that your GitHub account is using. And when we type in the command git status, it would show us that these files are untracked. So if we are seeing the red color, it means that Git is not tracking these files. And to track those files by Git, we have to type in the command git add dot. So tracking the files means you are staging the files. And you can type in git add the file name, but since we are using dot here, it would stage all the files that are in the repository. And after you have staged the files, you have to commit those files. So commit basically means that you are pushing those files to be tracked by GitHub. So all the commit message, the commit must always accompany a commit message. So here I'm typing it git commit -m, and a standard practice to write commit message is that you should write your username followed by the changes that you have made. So since we have made a MERN boilerplate, I am typing my username followed by a MERN boilerplate. So now we have a local directory which is tracked by Git and a repository hosted on GitHub. We have to push the files from local to the remote repository. For that, we have to create a link between them. For that, the command is git remote add origin and the link. So link would be the URL of your repository. For us, that is github.com/statusneo/konfhub. And you can check whether the link is created or not by typing in the command git remote -v. And after that, we have to just push the changes. For that, the command is git push -u. origin, that is the link name, and main. So this is a new feature, I would say a new update for GitHub, that they have switched from the default branch as master branch to the main branch. So now you have to type in main, and then these files would be available on your GitHub repository. So anyone can come and collaborate on it. Now the next step would be setting up CI/CD using GitHub Actions and Docker. So GitHub actually was traditionally only meant for collaboration and source code management, but in 2019 it launched its own CI/CD engine called GitHub Actions. So CI/CD basically means continuous integration and continuous deployment. And GitHub Actions is used to run tasks which are predefined in a declarative format, that is YAML, and they run on various events. So there are different events on GitHub, like push action, the pull request action, or creating a release. And we can create GitHub Actions via two methods. The first method is by writing a JavaScript declarative function, or by using Dockers. So we are going to focus today on Dockers. And Docker is basically a platform as a service, which is a lightweight cross-platform image that can be used on any platform. So suppose your repository is worked upon by 100 collaborators. They might be working on Linux, Mac, Windows, or any other system, and can be using different versions of the same software. So this is a month application, and the current version of Node is 14, but people might be working on version 10, version 6, etc. So for that, Docker can be used so that everyone uses the same version. Then I would switch to hub.docker.com and create a repository there. So this is my account on Docker Hub. I would click on create repository, and the repository is created. I would type in any other name and make it as a public repository and click on create. So this repository is now made. The next step would be to add credentials of my Docker to the GitHub repository. So for that, if you see on the top bar, you can see a settings button there. And in the left navigation bar, there's a secrets button. It would give you the secrets page, and you can add a repository secrets. And here you would type in your Docker ID and your Docker password. So that those are saved here. I would not show them obviously. And so bringing an analogy, there are two terms related to Docker that are Docker image and Docker containers. So we can take an analogy of class and object if you have heard about object-oriented programming. So a class is a template and object is its runtime instance. Similarly, a Docker image is a template and Docker container is its runtime instance. So to create a class, we write programs in Java, C++, or any other language. Similarly, to create a Docker image, we write it in a Docker file. So the syntax for the Docker file here is this. So we are using Node 10 Alpine image as our base image, and we are copying the files from the local workstation to the Docker image and running the command. So npm install and npm run scripts can be run here. So there is a difference between the run command and the cmd command. The run command basically are associated with the Docker image, and the cmd command is only run when you launch the Docker container. Then we move on to create a GitHub Actions. So for creating GitHub Actions, you have to create a .yml file specifically in the .github/workflow folder. And so here the name for the GitHub action is CI/CD with GitHub Actions and Docker. And as I mentioned, actions only work for specific events. So here I have created a on push event. It would only work whenever a push is created to the repository. Then the job build is created. It works on Ubuntu latest. You can use any machine you want. The next step is inclusion of actions/checkout. So this is GitHub Actions own repository, the checkout repository, and it copies the entire workflow from your GitHub repository to the Docker image. Then we type in the Docker build command to create the Docker image by using the Docker file. It's a basic syntax which uses the Docker file we have created previously. Then we log into Docker Hub using the secrets we just created and push the Docker image to Docker Hub to the repository that we had created previously. So this action would run for a few minutes and give us a completion notification. So this is a screenshot attached for all the success running of this Docker actions. And if you go back to the Docker Hub and see our repository, we would see the last push. It would give you any time, but it has been pushed to the Docker Hub. Okay, so our Docker image is now successfully hosted on Docker Hub. We have to try and test by running it locally. So I will move back to my Linux machine and run the command docker images and see there is no image locally present. Then I will pull this image. So I would use the command docker pull your Docker ID / your repository name. For me, that is Nishkarsh / OSS days. And then I would run the Docker container. For that, the command is docker run -it -p, and -p is used for port mapping, and -it is for getting the interactive terminal. And you would see the output that your one application is running live, and it would show where it is running. So for me, it is running in localhost 3000, and it would give me this. So this is not the application that Shreya was working on. I have created my own application using Brad Traversy's most famous tutorial. I would link it in the description of the YouTube video as well after this. So after we have done all of this task, now we have to deploy it. So till now we were working for developers, how developers would get a cross-platform Docker image and collaborate on GitHub. Now we have to deploy our application for the end users. For that, we are going to use Azure Cloud, and we are going to launch create infrastructure for it using automated engine called Terraform. So Terraform is basically a tool created by HashiCorp. So this is my Azure dashboard, and I would connect my Azure CLI from here, and it would give me a CLI. I'm using Bash rather than PowerShell. So if I type in AZ account list, I would get an ID. So I have obviously hidden it, but ID is your subscriber ID. And after that, you can create an authentication. So similar to the Docker Hub authentication that we created in the secrets, we have to create a secrets file for this as well, Terraform as well. So if we type in this command, AZADSP, that is Azure, AD is for administrator and SP is for service principal, we would get our credentials. So I have hidden the credentials, but you have to copy them and create a Terraform file. So this would be your provider.tf file. So one quick fact, Terraform uses its own language called HashiCorp language, that is HCL, and it is declarative in nature. So this would be a Terraform file. So the version is, you can use any version or the latest version. Subscriber IDs fetched by using the AZ list, and the client IDs and password were generated using this command. And then we will create the main.tf file. So Terraform runs the main.tf file by default, and we are only creating a resource group here. So for that, we have to use the keyword Azure RM, that is resource manager /_ resource group. And I'm naming it Nishkarsh because my name is Nishkarsh, just a wordplay. So in my Azure CLI, if I type in ls, I would see my main.tf file and provider.tf file. Then I would run the Terraform script by using Terraform init first. What Terraform init does is it goes to all the TF files present in the directory and checks for any plugins or dependencies to be downloaded. So it would download the Azure dependencies when I type in init. After that, I would run the Terraform plan command. Plan command basically gives us a preview. If we create the infrastructure, what will be created? So you would see +++ means these are created. If you see --- on destroy, it means that infrastructure would be deleted. So Terraform basically works on change management. So if you are running the Terraform script again and again, it would not create or destroy the entire infrastructure completely. It will only work on the change. That is, suppose you have launched 100 containers, it would only destroy 99 if you have specified it. Otherwise, it would not destroy anything. So to launch the infrastructure in reality, we have to run the command Terraform apply and type in the message yes. If you want to remove the CLI part, you can type in the message Terraform apply -auto approve or -auto approve, and it would not ask you from the terminal to type in yes, and it would create the infrastructure. So if I go into Microsoft Azure again, I would see the Nishkarsh resource group is created. So our infrastructure is ready now, and our developer environment is also ready. The only thing left is to deploy our deploy our Node.js application on Azure Web App. And for that, I'm going to automate it using GitHub Actions again. So coming back to my Azure portal, I would click on create a resource. And after that, I would choose this, that is a web app option. And on this window, I would use my subscription, that is for Azure for Students. Resource group that I just created, Nishkarsh, by using Terraform. And then instance details can be taken off. And these are basic informations that you can put in. A runtime stack is 10.6 because I was using Node 10. And then we would create this web app. So you would see the deployment is in progress message, and it would run for at least a minute before the deployment is successful. Once the deployment is successful, you can go to resource, click on go to resource button. And you would see on the top navigation bar, you would see get published profile. So this is the authentication we would put in GitHub Actions. So you will click on that and it will download a notepad file in your machine. We then switch back to the GitHub repository and go to the secrets file. And we will copy the contents from the notepad file we just downloaded and put a secret called Azure Web App Publish Profile. And we then go to the Actions tab, and we would see we already have a CI/CD using GitHub Actions and Docker Actions already running. That was created by us manually, but we can also use GitHub Actions that are publicly available by the community or organization. For that, you can click on New Workflow button here. And Microsoft Azure has its own official GitHub Actions to deploy Node.js application to Azure Web App. We would use it right now. So you have to click on set up this workflow. And it would give, and after that, this is the GitHub Actions we would get. So again, we are going to use the on push. This is all already written, so we do not have to change anything. Just this, the Azure Web App name should be your name that you created on the Azure platform. And in the build steps, you have to replace the install command with your commands. So I have used npm install, run client install, and run build. And publish profile takes the secret which we just created on GitHub Action secret. Then it would run, and it would run for a long time. It ran actually for 14 minutes for me, sorry, 12 minutes for me. And then we would see the output on Azure Web App. So that's all from my side and Shreya's side. These are the references, and the slides would be shared with all of you. You can obviously go through them. So now we would be taking some questions.
That was really awesome session by Shreya and Nishkarsh. Yeah, there was some bit of like extended time, but that's totally acceptable. And like there are so many engagements going on in the comment box. So I'll just quickly go through it and just see if there are any questions. And meanwhile, participants, I would request to post questions if you have any for Shreya and Nishkarsh. So as of now, we don't see any question, but okay. So how about like we'll be sharing the YouTube live link with both of you guys, so you can hop into the comment section and you can answer if there are any questions. And also, yeah, don't forget to share your slide deck if you have already with you. So you can share
Yes, we will
directly with
share
the
it.
participants in the comment section, and the people
Sure.
can go through it. And that was really awesome session by both of you. Like that was detailed, and like we see a lot of people enjoyed it actually. So that was really awesome. Thank you, Nishkarsh and Shreya, for joining us for the conference today, and we hope to have you guys again in our future events.
Thank you, and thanks for this
Definitely.
opportunity. And I loved giving this session with Shreya. So it was a wonderful opportunity.
Awesome.
Yes, definitely. I mean, you guys did an amazing job in hosting this event. I mean, I cannot even begin to imagine how much hard work has gone into organizing because, I've been there and I know, like, what happens in the
No
backend.
problem.
So yeah, I mean,
Yeah,
thank
we
you
are
for this
really glad. But
opportunity.
before you guys leave, we have just one question from Neha. So I would like to show it to you so that you can just answer. Yeah. So here it goes.
Okay, so configuration file. Actually, we have used multiple configuration files. So can you please explain which one? Because we are using for Docker as well, GitHub Actions as well, and Terraform.
Okay, we have another questions. So this question is from the Edureka channel where we are also restreaming it. So don't know whether this question is relatable to this session or not. I'll just share it with you guys, just in case if you guys are aware of this.
Okay, that is an amazing question because I have worked both on GitHub Actions and Jenkins. So the major issue that I encountered on using Jenkins was that we have to run it on a local host, and running it on cloud does not have a great support. And GitHub Actions is actually backed up by Microsoft and has amazing support of the community, and open source community is extremely vast, and there is a lot of already made up GitHub Actions in the marketplace, which is free to use. So GitHub Actions does have a greater reach and usage than Jenkins, and also Jenkins is not very collaborative because we have to work it on the local host rather than on a cloud. And
Okay,
the second part of the question, can we use GitHub Actions to deploy applications in Azure functions? Yes, we can. Even Azure has created their own official GitHub Action for the same, and I would come in the comment section and link it to you very soon.
awesome, awesome, awesome. So I think that answers to the question, and yeah, with that we are good. So thank you again for joining us, and we would love to have you guys again for our future events. Thank you,
Thank
Nishkarsh.
you,
Thank
and
you, Shreya.
take care, everyone.
Thank
Thank
you.
you. Bye bye.
Okay,
Take
thank
care,
you.
everyone.
Okay, all right, guys. So that was Nishkarsh and Shreya, and with this, we have actually come to the end of the forenoon sessions, and right now this is the time for the quiz. So yeah, this is really exciting part. So we'll just share the quiz link with all of you guys so that you can play. Just let me share my screen. All right, so here you go. Hope you guys are able to see my screen, and here is the quiz. So the link is com.me/oss-quiz1. So you guys can go to this link and play out the quiz, and obviously the top three on the leaderboard will be considered as winners, and they will be standing a chance to win rupees 500. Also, guys, meanwhile, I'll show like how the leaderboard is going on. So I'll share my screen and show you the leaderboard. Yeah, so here we go. And we have Sai on top with 9 correct answers. So as of now, we have received 50 submissions. So guys, since we started the quiz a bit late, so we'll be closing it by 2:05. Hope that is fine. And yeah, try the quiz and get a chance to win rupees 500. So yeah, so now we have Gauri Prasad Sharma as the top on the leaderboard with 10 correct answers. Okay, so we have Gauri Prasad, Sai, and Ravi Shankar on top 3. Let's see if we can have somebody with all the 10 correct answers and all the top 3 leaders as top like 10 correct answers. So we still have 6 more minutes and we have got 61 submissions as of now. Also, guys, if you are not able to find the link, so the link is there in the comment box and also below the screen. As we have 5 more minutes, so requesting all to participate quickly. Okay, so we have Gauri Prasad, Ravi Shankar, and Sai on the top 3. And we have 71 submissions as of now. Okay, so the winners leaderboard is constant. We have Gauri Prasad, Ravi Shankar, and Sai. Folks, we have 3 more minutes. We have got 79 submissions. We have 82 submissions and we have almost just 1 minute. Okay, so we are just about to end the quiz. And we will pause this session here itself because when it strikes 2, okay guys, so it's 2 and yeah, so this is the leaderboard and the final winners will be announced at the end of the conference. So stay tuned with us for the conference and all the winners will be announced at the end of the day. All right, so with this we have come to the end of the quiz. Also guys, those who have missed winning a chance for the quiz, then we also have one more round of quiz at the end of the day, which will be at 4 p.m. so you can stay back and attend that quiz as well. So now we'll just quickly run through the learning resources which we have and what do we have for tomorrow. So just let me share my screen and show it to you. Okay, so guys, this is the website we have. So if you haven't registered for the workshop yet, so our registrations are still live, so you can go directly and register for the event, and the registered participants will be getting notification for tomorrow's workshop with the live URL. Also, since many of you were asking for the learning resources we have for the event, so it's here. You can go to the learning section and you can find all the learning resources which we have. So you can find different learning resources with that you can get started with. Also, as I mentioned, we have workshop tomorrow coming up. So we have 2 amazing sessions in the workshop. So the first is by Vivek from Microsoft on Kubernetes 101, and then we have Karan from GitHub on CI/CD with GitHub Actions and Kubernetes. Also, participants, we have amazing challenge for you. This is called Azure the Challenge, which is totally meant for the OSS Days conference. So you can take up the challenge and you can complete any of these learning paths. After completing this, you just need to share it on social media along with your learning badge and using the hashtag OSS Days and tagging KonfHub. With this, you'll be receiving a Azure Hero badge. So guys, I would request all of you to go up and take up the challenge to win Microsoft Azure Hero Badge. So with this, that's all about the details of the conference. Just let me run through the agenda for afternoon. Pardon me, I know I'm just running a bit late, but I'll show the agenda for afternoon session and then we can get started. Okay, guys, so we have our quiz time ended and now we have the agenda for afternoon. So we'll be starting with Nilesh Gule and his session will be on serverless event driven container with KEDA. Then we have Rajat and Vineela at 2:35. Then we have Ashirvad at 3:10 p.m. Then we have Shubhangi as our last speaker at 3:45 p.m. And after that, as I mentioned, we have another game time at 4 p.m. And after that, we will be having the closing remarks and the announcement of the quiz and referral winners. Also, guys, here is the link to the learning resources, so you can go through it and find all the speaker slides and the learning resources. Here is the link for Azure Dev Challenge. It's already on the website, but still you can find it ossdays.confhub.com/Azure. So you can participate in it and earn Azure Hero Badge. Also, to make this whole conference successful, we had so many helping hands. We had 27 community partners. So here are this. These are the community partners who have supported us for the whole conference, and we are really thankful to them. Apart from the community partners, we also have Edureka as learning and streaming partner. So this whole conference is being streamed to Edureka's YouTube channel as well. This whole conference is being sponsored by Microsoft Azure. So we are really thankful to Microsoft Azure with providing us with the learning resources and the developer content, which you can find on the website. Also, folks, if you are liking the event, we would love to hear from you. For that, you can make a post on Twitter along with hashtag OSS Days and tag KonfHub in social media posts. So with this, I have nothing much to say about, and we'll totally go to our first session for the afternoon. And also, folks, you can subscribe to KonfHub for getting the regular updates on technical events and conferences happening. With this, I would introduce Nilesh Gule. Hello, Nilesh.
Hi, are you able
Hi,
to
how
hear
are
me?
you? Yes,
I'm doing
yes.
good. Thank you. How about
Awesome.
you?
Yeah, I'm doing good. And we are really excited to have you as a speaker for the conference. And you're going to be the first speaker for the afternoon session. And all our participants are really pumped up and excited for your amazing session. So going further, can you give a quick introduction about yourself, like what you're doing and what your session is going to be?
Yeah, sure. I
Awesome.
hope I don't make people sleep after
No.
lunchtime. And if somebody is feeling sleepy, I'm exciting them by making this session. So my name is Nilesh Gule. I've been in the IT industry for almost close to 19 years now. I started my career back in 2003, and I started it in Bangalore. I was in Bangalore for about 8 years before coming to Singapore. And for last 10 years, I've been living in Singapore. And currently, I work with Prudential as a big data and cloud solutions architect.
Awesome. So I see your screen is already there. So I'll put it on the screen.
Okay.
Awesome. Yeah, you're live.
Okay. Hi, everybody. Thanks for joining this session. So my name is Nilesh Gule. My Twitter handle is @Nilesh Gule, and my blog is at handsonarchitect.com. So a bit about myself. I was born and brought up in Goa. And as I said, I did my first job in Bangalore, or I started my career in Bangalore. So Bangalore has a very special place in my heart. I also like bisi bhat. That's one of my favorite dish, and I really love the Bangalorean food. So apart from that, I've put my social media handles here. And when I'm not talking about technology, I also like the game of cricket, like most of the Indians. And if you want to talk about cricket, I'm more than happy to talk about it. I'm also the co-organizer of Azure Singapore user group, and we host regular virtual meetups. In case you are interested in any topics, most of the upcoming Azure related stuff, feel free to subscribe to our channel. It's one of the most well-run Azure meetup, I would say, in the Southeast Asia. So coming back to today's session, I'll be talking about serverless containers on Azure with KEDA. So let's first talk about what is KEDA and understand where does KEDA fit in and why do we need KEDA. And then in the second half of this session, we will be talking about deploying objects or deploying containers onto ACI using KEDA. So before I move on to KEDA, let's try to understand what are the options for scaling containers on Kubernetes. So this session, I assume that you know a bit about Kubernetes, you know a bit about Docker, you know how containers work, and some of the basic concepts related to Kubernetes, like what are deployments, what are the pods, what are like replica sets and things like that, and how they work in general. You don't have to know everything in depth, but at least a basic understanding of this is expected. So when it comes to scaling in Kubernetes, Kubernetes has different constructs which allow us to scale based on the workloads. First one is called as horizontal pod autoscaler, which allows us to scale the pods based on some sort of resource. So let's say we have a Kubernetes cluster which has got X amount of resources available at its disposal, and we have scheduled some workloads. And then there is, let's say, increase in the demand. We can look at things like how much resource is being consumed. It could be CPU, it could be RAM. And based on these, we could scale the number of pods. This is what horizontal pod autoscaler does. And as long as there are enough number of resources available on the Kubernetes cluster, we can scale the number of pods. But what happens if, let's say, we have a requirement? The horizontal pod autoscaler realizes that I need 100 instances of the pod to be scaled, and there are only resources available for scaling up to 80 pods. Now we are short for 20 pods to be scheduled. In that case, we can look at the second option where the whole cluster itself can be autoscaled. So when the horizontal pod autoscaler is running short of resources and there are pods waiting to be scheduled, that is where the autoscaler kicks in, the cluster autoscaler, and that can also help to scale the cluster. The third one is manual scaling, where at certain point of time, let's say there is a very predictable workload which you are expecting for your application, like a month-end process which runs, and that particular time, let's say on 29th, 30th, 31st, these are the 3 days where you need more number of resources. So you can manually go and add resources to your cluster, and you can manually scale your workload. Now, all these, they work within the Kubernetes cluster resources itself. Where KEDA comes into picture is, what if you have to scale based on factors which are outside of the Kubernetes cluster's resources? So we talk nowadays more about real-time processing, right? And there are many frameworks, there are many middle tier applications, or like things like Kafka, which work outside of Kubernetes, or which can be deployed outside of Kubernetes, or it could be a messaging infrastructure, let's say RabbitMQ, for example. There could be an instance of RabbitMQ which is sitting outside of the Kubernetes cluster, and there are messages or events being streamed into these Kafka or RabbitMQ clusters. And the Kubernetes cluster doesn't have information or enough knowledge about what goes on in these the messaging infrastructure. You might want to scale based on the number of messages, and that is where KEDA comes into the picture. It helps us to scale the workloads on Kubernetes cluster based on events which are outside of Kubernetes. So I'll show you one example before I move on to KEDA, which is of the manual deployment or manual scale. I have a deployment here on my Kubernetes cluster, which is called as RabbitMQ producer. And let's say I want to scale it. Currently, if you look at the output here, there are 2 instances of this deployment running and both are up to date. Let's say I want to scale it to 5 instances. So I can run a command using the kubectl or kube control saying scale the deployment, name of the deployment, which is RabbitMQ producer deployment here, and giving the number of replicas. So I provide the number of replicas as 5, and you can see that immediately, since there are the resources available on this cluster, it scales up to 5. Now, at a later point of time, I realize that I don't need 5 instances. So I go and scale it down, saying now bring it down to 2. So again, we see that immediately this is brought down to 2 instances. And if I do again get deploy, I should be getting only 2 instances of this replica or this deployment running. So that is the manual process. Now let's see how KEDA comes into picture and helps us to look at the problem which I was saying, where if your source is external, that is one scenario. The other scenario is if you have a workload which is very unpredictable. So let's say we have scenarios where we are doing a promotion. It could be Deepavali, or it could be New Year, Christmas, Eid, or anything like that. Or we are running these Amazon like events like Halloween or any other special promotion events where you don't know exactly how much resource is required, and you don't know exactly how much the number of hits are going to come, or how many requests are going to come to your server. So in this unpredictable scenario, you might not want to keep your cluster running all the time. You might want to keep it very minimal, and then scale based on only the need which is required, or only when the burst happens, very short duration of time. And you don't even want to, let's say, add the resources to your cluster. You want to utilize the serverless power. So in this case, you can have a very small Kubernetes cluster, and this can extend into the serverless infrastructure. And based on the number of events you have, you can say for a very short burstable period, I want to schedule my workload onto the serverless infra. And once that processing is done, I don't need that processing power. So I scale back down to my minimum or my regular size. So the way KEDA does this is it sits on top of the existing Kubernetes resources. It doesn't create anything outside of the Kubernetes cluster. It adds 2 things. First one is the agent, which looks at what is your object or what is your workload which needs to be scaled, and what is the trigger for that. Now for the trigger, it creates its own matrix adapter. So that is the part which is shown here in the screen about the matrix adapter. And this matrix adapter is the one which creates a horizontal pod autoscaler, which can scale that particular target instance or target object from 0 to whatever number we specify when it needs to scale up. And same way, when the workload is over, when the processing is finished, it can scale it back down to whatever number of instances we specify. And this happens based on the external source of the trigger. So let's look at how we can deploy KEDA. Now we understood how KEDA works. So it's like an extension to the existing Kubernetes cluster and looking at external sources of data. If I want to deploy KEDA onto my Kubernetes cluster, there are 3 options which are provided by the KEDA project. KEDA is, the full form of KEDA is Kubernetes-based event-driven autoscaling. This is a project which is open source project developed by Microsoft and Red Hat initially, but now other people are contributing to it. So for a deployment, we can use either the Helm charts, which is like the package manager for Kubernetes, or we can use Operator Hub, which is again another option to deploy the custom applications onto a Kubernetes cluster, or we can also use direct YAML declarations. So all these 3 options are available. In my case, I'm using Helm charts to deploy, and I will show you later when we do the demo how I'm using this. For the application which I'll be using for this demo, it's a very simple .NET Core application. It's called Tech Talks. So imagine it's like an application which is used to manage technical events. So there is a way or a API exposed in .NET Core which allows us to generate, let's say, some number of tech talks. These tech talks, they get pumped into a RabbitMQ as a series of messages. And then there are consumers which consume those tech talks. So let's say we need to send emails to the people who send those tech talks, or any processing has to happen. This is done by the consumers. And in this case, both the producer and the consumer, they are deployed as Docker images or Docker containers, and RabbitMQ is deployed using Helm. So if you look at this repository in my GitHub repo, it has all the source code that I'll be showing or I'll be using during this demo. So we use manifest files to describe the deployments and the services. So the producer and the consumer, these are deployed using deployment, which is a higher level construct in Kubernetes to deploy something onto the cluster. And then to expose it to the outside world, we use a service. We use Helm charts to deploy any third-party applications or services. So for RabbitMQ as well as KEDA, to deploy both of these, I'm using Helm charts. To visualize what is going on inside the Kubernetes cluster, I use Octant, which is one of my favorite tools. And at times, I also use kubectl to interact with the cluster, or kubectl. So all this is available on my GitHub repo. I'm also using another construct, which is called as virtual node. So KEDA can run in a physical Kubernetes cluster or normal Kubernetes cluster, and it can also extend into the serverless infrastructure. So virtual node is a construct which works with a virtual kubelet. So it's like an agent which runs on every node in the cluster. In this example, we have a basic Kubernetes cluster, let's say with 4 VMs or 4 nodes. And then for that burstable kind of load, which I was talking about, I want to extend that into, let's say, Azure container instances. Now, this virtual node is supported by different cloud providers. They have different implementations. In terms of Azure, it is Azure container instances. When it comes to AWS, it is AWS Fargate. There is also Azure Batch GPU provider. OpenStack has their own implementation. So different providers have their own implementation for supporting this virtual node. So we will be using Azure container instances. And from the management point of view, or the way we interact with this virtual node, there is nothing that changes. It's just that when we create the cluster, the Azure Kubernetes Service or AKS cluster, we have to provide some additional settings, additional configuration to provision this add-on service. And then we are able to schedule the workloads onto that serverless infrastructure. So the way we will be working with this is, I have created a virtual net or VNet, and in that I will be deploying all these resources. So my AKS cluster or the Kubernetes cluster gets deployed into this VNet called as KEDA VNet, and that gets split into 2 subnets internally. One which is used for the basic set of Kubernetes cluster, which is, I've created this as just a single node Kubernetes cluster because I want to use the serverless infrastructure for all this extension. And all the consumers that I have, they will be scheduled specifically on the serverless infrastructure using ACI. So for that, I create a separate subnet. So my producer and RabbitMQ and as well as KEDA, they run on the normal Kubernetes cluster and the normal subnet or the KEDA AKS subnet. And the consumer, which gets scheduled onto ACI, it runs into the separate subnet. So what we are trying to see in the end, or when this example is over, is we will be using RabbitMQ as an event source, and we expect KEDA to auto scale these consumers into the Azure container instances, which is our serverless infrastructure. So let me go into the demo mode and show you how all this works. So here, are you able to see my screen? Is the font okay? Or you want me to increase this? Okay, I assume it's fine. So, okay. So you can see the output of the first command here, which is I'm trying to get the nodes. So you see the first node. This is the regular node, which I was talking about, where the AKS cluster is created. And then there is the virtual node. So I have enabled the virtual node add-on for my AKS cluster. And you see, this is the a virtual node ACI Linux cluster or node, which is shown here. And this is running on ACI 1.3.0 version. And I've also created the base Kubernetes cluster with 1.19 version of Kubernetes, which is the latest available in Southeast Asia at this point of time. So when I deploy KEDA onto this cluster, KEDA creates a horizontal pod autoscaler for its own usage. And I can get this information by running this kubectl get HPA command. And you can see that this was deployed about 16 hours ago. And there is a range which is given here between this is unknown and 5. And the range for the pods, which I want to scale, is from 1 pod to 30 pods maximum. So I specified this in the configuration somewhere, and KEDA picks it up and deploys this. So let me now go and show how we are going to deploy. So before I start deploying, let me just set up some watchers here. So I want to show you that how does the deployment scale and what are the deployments which have happened onto this cluster. So if you look at the output here, when I say get deploy and I set a watch on that, there is the RabbitMQ consumer deployment, which has been done about 17 hours ago. And currently there are no consumers running. And there is the producer deployment also, which is 2 instances of that are running. So in the deployment manifest file, which I used, I specified 2 replicas of this deployment to be created, and both of them are up and running here. And in terms of the pods which are running, let me also set the watch on that. So you can see the RabbitMQ, there is 1 pod of RabbitMQ running, and there are 2 pods of the producer service running. So that is the 2 instances which we see here. Now what I'm going to do is I want to generate the load. I can also show you this in Octant. So Octant is the visualizer which I was talking about. So if I go in the Octant UI, I see the same output. So it will show me what are the workloads available or what are the workloads running on that cluster. So we see the same output that we see on the UI. So let me go into the container instances in Azure portal and make sure that we don't have any container instances running at this point of time. And if I look at the RabbitMQ queue as well, right now, there are no messages in this queue to be processed. So let me go and generate a workload for this. And for that, I have already gone and done the port forwarding. So I can, so let me show you how that is done. So I have done the port forwarding for my producer service on 8080 port. And for the management UI of RabbitMQ, I'm doing port forwarding on this default 15672 port. And that is how I'm able to access that RabbitMQ management UI. So now I will go and generate the workload using Postman. And for that, I use that localhost address to use the port forwarded address to the TechTalks API. Generate is the method which is used to generate a dummy workload. And let's say in this case, I want to generate 2000 messages. And if I get the status output as 200 here, that means those 2000 messages were generated. And this UI gets refreshed every 5 seconds. So we can see now there are 2000 messages ready to be processed. Now we should see the KEDA kick in, and it should try to create the instances, and it should try to scale the number of consumers because there are messages to be processed. So this will take some time because I have given a polling interval in my configuration of KEDA to say, look after every 1 minute or so. This interval is configurable. So within a minute, it should start putting request for creation of Azure container instances. And you can see here, now it has already requested for 4 containers to be provisioned. Now we can also see this in our watchers. So if I go back to the watcher, you see the output of watcher that initially it was 0 for consumer deployment, and it started from 1, then it went to 4 because it realized that 1 is not enough to process all the messages. It is progressively increasing the number of deployments. From 4, it went to 8, from 8 to 16, and finally from 16 to 30. And you will also see that incrementally this is changing because out of those 30 which are requested, as and when those ACI container instances are ready, this number also keeps changing. So this 10, 11, 12 is the number of instances which are ready. And below, you also see the way the pods are getting scheduled. So now we have 23 ready. So if I just scroll up a little bit, you can see that it is creating, waiting, and then in a short while, it will also be running, pending and running. So it goes through that life cycle of pod creation where the request is sent to the ACI. It will pull the image and it will start running that particular pod. Now we have, I think, all the 30 pods ready, and you can see that the number of consumers here, all 30 are up and running, and we can see all those 30 here in the output of the RabbitMQ consumers. The point to note here is each of those consumers, they are scheduled or they are configured to pick up 50 messages at a time. So that is the prefetch count which shows here. So every consumer, when it starts, it picks 50 messages, and I have introduced a fake delay of 2 seconds. When the message is processed, it will try to introduce this kind of heavy workload by introducing a 2-second delay. And we can confirm this by going into the logs. So let me go into one of these containers and see the logs of that container to verify that there is this message getting written saying a particular tech talk was processed, and it took about 2 seconds to process that. So in the containers, if I click here, and if I go into the logs of that container, you can see that when the container started, it connects to the RabbitMQ and it says I'm inside the receiver code now. It picks up a message. It writes the details of that message here saying the tech talk ID is 603, tech talk name is a random name, category is 1, level is 1, and then it writes a message saying at this particular time, 8:57:17, it finished processing this. And if we look at the next one, it is after 2 seconds. So 8:57:19, next one will be 21, and so on and so forth. So this is when it scales up. Now, if we go into our RabbitMQ, we have finished picking up all the messages, and all those 30 consumers, they are running at a full speed. And you can see that all the messages have been finished processing. There is nothing to be processed at this point of time. And in few seconds or few minutes, we should be seeing this scaling down as well. So we also have a configuration in the KEDA, which I'll show you shortly. What is the cooldown period which we want for these containers to wait before they start tearing themselves down, or before KEDA starts tearing them down. So you can see here right now, all 30 are running. And let me go back into the watchers. Here also, we see that all 30 are up and running, and the state of the pods is everything is running as well. In a short while, we should see that this will trigger the scale down, and the pods which are running here, they will get terminated, or they will be requested, send the termination request. So while that is coming up, let me show you the code, how this is done. So I'm using the consumer deployment here for virtual node, and the configuration of this virtual node is similar, or the consumer is similar in the first half, where we specify it's the type of deployment, what is the metadata for this particular consumer. So I'm giving some labels like it's a RabbitMQ consumer, the replica is one here, what should be the match label for the service to pick this up if I'm exposing this consumer as a Kubernetes service. And if you look at the specification of the container, we are picking this from Azure Container Registry with this tech talks consumer, and there is a tag for the image, RabbitMQ KEDA 3.1. Then I'm providing some environment variables, like what is the name of the environment. In this case, it is set to development. What is the RabbitMQ host name? What is the username, password? And this is the value, which is the RabbitMQ batch size, which I'm taking as an input parameter or an environment variable. I can change this from 50 to 100. I can redeploy this, and next time that consumer runs, it will pick up 100 messages in a batch. So that is how I can configure the amount of messages which get picked up in one single batch. And then I'm specifying some additional properties, like what should be the image pull secret when I pull this image. So when this container gets scheduled onto the serverless ACI infrastructure, it requires the image pull secret to connect to my container registry. So I have registered this ACR image secret as a Kubernetes secret in my AKS cluster. And then I'm specifying some additional properties like the DNS policy, DNS config, and all, which allows me to say, this is how I want my workload to be scheduled specifically on ACI and not on the base Kubernetes cluster. So this I have explained in one of my videos on my YouTube channel. So I will show you at the end of the session how you can access my YouTube channel. But the most important part is these two configurations, which is the node selector and the toleration. So this uses a construct in Kubernetes called as taints and tolerations. What I'm telling this API of Kubernetes is, I want to schedule this particular container on the node which has these labels or these properties. It needs to have a role as agent. The operating system for that particular node has to be Linux, and the type has to be virtual kubelet. So when I create that or when I enable the add-on, the virtual kubelet add-on for my AKS cluster, it puts that taint onto the virtual kubelet cluster or the virtual node. And that is one way in which I specifically direct this particular container to be scheduled on that ACI infrastructure. The second thing I do is tolerations. So this is to specify that when my operator is equal to Azure, only then the key is virtual kubelet and the provider is Azure, schedule this workload onto that particular ACI container. This is how I make sure that all these workloads, the consumers, they don't get scheduled on my normal AKS node, but they get scheduled on the ACI node. So this is very important setting which decides how the scheduling works. And apart from this, now coming back to the deployment of KEDA and the KEDA auto scaling related settings, let me show you a couple of things. First one is, how do I deploy KEDA? So as I said earlier, I'm using Helm to deploy KEDA. This is how I deploy. I use a PowerShell script, but if you don't want to use PowerShell script, you can just run this command directly on your AKS cluster or Kubernetes cluster. It is Helm install. The name of the installation is KEDA. I'm getting it from KEDA core/KEDA repository, and I'm putting it inside the namespace called as KEDA. And with this, we will have the KEDA installed on our cluster. The next thing is, once the KEDA is installed, the additional configuration I need for the link between my source, which is RabbitMQ in this case, and the KEDA horizontal pod autoscaler. That is done using something called as the scaled object. So this is a custom object or custom resource provided by KEDA using this V1 Alpha 1 API of KEDA. And we have the regular metadata here, like where it should be, which namespace it should use, what should be the name of the deployment. So this is how I link this particular scaled object to my RabbitMQ consumer deployment. When I deploy my RabbitMQ consumer, that is named as RabbitMQ consumer deployment, that particular deployment. And I'm saying this instance of scaled object should look at this particular consumer deployment. So in the spec, you see that the target ref here, the deployment name is exactly the same as what we specify as the name for our consumer deployment. And then there are some additional properties like the polling interval. All these are optional. Like the default is 30 seconds. So every 30 seconds, it will go and poll and see if there are any messages to be processed. I've set this as 1 minute. So every 1 minute, KEDA infrastructure or this KEDA objects will go and check, are there any messages to be processed? And are there enough consumers to process those messages? If there are not enough consumers, then it will scale those many consumers. And I'm saying the range. So minimum is 0. I'm saying if there are no messages to be processed, we can terminate all the running consumers. And when we want to scale up to 30. So that is why when it was scaling, you saw that it went from 1 to 4, 4 to 8, 16, and After 16, it stopped at 30. It didn't go to 32. And finally, this is the part which links the source of the event. So what is the trigger for all of this? In the triggers section, we specify that the type of the trigger has to be RabbitMQ. And based on the type of our source, we will have to provide additional metadata. So in this case, I'm providing the name of the queue, which is named as hello. What is the queue length? So this is the number of messages in that particular queue. As long as there are 5 messages in the queue, 5 or more, KEDA will keep on scaling the consumers. And then authentication reference is a mechanism which stores the credentials to connect to this particular queue. So we create something called as authentication, trigger authentication. And this is again a custom resource provided by KEDA. And in this, we put the host information, and the host is storing the RabbitMQ connection string in encrypted format. So that is created again as a Kubernetes secret. So you see here, it's the type as secret, and we have the data as RabbitMQ connection string in that. This is all base 64 encoded. So we are storing the final string, or the string which is stored inside this base 64 is the AMQP format for the host to connect to the RabbitMQ. So all this is put inside a secret. That secret is linked to the trigger authentication, and that trigger authentication is linked to the scaled object. So that is how KEDA is able to identify which source it has to look at and what is the range it has to scale from, let's say, in this case, from 0 to 30. So now let's go back and see what has happened. Did the scale down happen? So you see that all those 30 instances which were created on ACI, they have disappeared. And if we go back into RabbitMQ, everything is back to 0. All the messages have been consumed. There are no more consumers here. And if I go into the octant as well, you see the pods, they are now back to what was originally the case. We had just the 2 deployments for producer. The consumers, they are all gone. And we can also verify this by, again, going back onto our watchers. And you see here, everything has started terminating. And all those 30 instances, they ran for a different amount of time. So some of them they ran for like just over 6 minutes. Some of them they ran for 5 minutes and 47 seconds. And then here the deployment is back to 0 now. So what has happened here is within a period of 7 minutes, we have scaled from 0 to 30. We have processed all those 3000 messages. And once the processing is done, we have scaled down back to 0. So with that, let me go back into the presentation. So we talked about this, the scaled object, and what are the main important properties. The kind, which is the scaled object of the custom resource provided by KEDA. The deployment name, where it links to, and what are the types. So now that we have seen the example of KEDA, let's see what are some of the features. First thing is it is event driven. So it is specifically designed to work with events. Any source which can provide real-time events, KEDA is well suited to process those events. It is enabling the auto scaling with very simple constraints or constructs. We have only 3 things to know here. One is that the scaled object, the other one is the trigger reference, and we just have to create a secret in that. There are many built-in scalers which are provided by KEDA project itself. So in the next slide, we will see which are them. It also supports multiple types of workloads. So what I showed was a deployment being scaled by KEDA or auto-scaled using KEDA. It also supports jobs. So if you're using Kubernetes jobs, those can also be scaled using KEDA. And most importantly, this is vendor agnostic. So although it is developed by Red Hat and Microsoft initially, it doesn't restrict us to use this on any other Kubernetes cluster. It can be deployed on any Kubernetes distribution. And it also supports Azure functions. So now coming to what are the event sources and scalers. The space here is kind of constrained for me. There are about almost 30 or close to 30 different scalars which are supported. So let's look at some of the major ones or important ones. If we start with Azure, there is support for Azure Blob Storage, Azure Event Hub, Azure Log Analytics, Azure Service Bus queues and topics, Azure Storage queues. If we go on to the other clouds, there is support for AWS CloudWatch, Kinesis Streams, SQS Service. On Google Cloud, there is support for PubSub. If we look at the messaging kind of infrastructure or middle tier applications or tools, there is support for ActiveMQ, Artemis, Kafka is supported, Prometheus, RabbitMQ. We saw RabbitMQ in this example. There is Redis streams as well as lists are supported, Lickless, NATS, Huawei Cloud Eye. And on the database side, there is support for MySQL, Postgres, Azure Functions is also supported, and there are many others. So I put a link here at the bottom of the slide. You can go through this and find out about all the other scalars as well, which are supported at this point of time. And these lists, it keeps enhancing. So when I started this particular KEDA sessions, I think there were just about 8 or 10. Now they have almost tripled over a period of 1 year. And KEDA is being adopted by many other vendors. I would say like databases were not there initially. MySQL and Postgres has been recent additions. Same way, NAT streaming, it was not in the initial supported list of scalars. So people are adding more and more scalars. You can also create your own autoscaler with the help of KEDA. There is something called as external scalar. So if all these what are by default provided doesn't suit your needs, you can also go and use something called as external scalar, and you can write your own custom logic which will use these constructs in KEDA. So in summary, what we looked at is KEDA. It's a very simple and single purpose lightweight component. It does one thing and it does it well. The thing that it does is it's scaling based on events. It doesn't try to do too many things. Its simple purpose is to look at event source and to help us scale a particular type of object. It can be deployed on any Kubernetes cluster. The only requirement is when we say any, it has to be minimum 1.16 version and above of the Kubernetes. It extends the Kubernetes with event-driven capabilities. It doesn't overwrite or it doesn't duplicate any of the existing functionalities. And it's very flexible to run side by side along other Kubernetes frameworks and applications. So you can mix and match. If you have some other framework which you have already deployed on your Kubernetes cluster, KEDA will still work side by side with that. And as I said, there are more than 25 autoscalers which are supported out of the box. Now, coming to some of the references, if you want to learn more about KEDA, there is the KEDA website itself, keda.sh, which has got very good resources to get started and to learn about KEDA. Then there are some resources which I've provided or links I've provided here to know more about the AKS cluster autoscaler. How does the virtual node work, horizontal pod autoscaler, and virtual kubelet. And then I realized that tomorrow there is a workshop on this 50 days from hero to zero. This is my favorite resource if you are new to Kubernetes. So the co-creator of Kubernetes, Brendan Burns, he did this series where he talks about different features of Kubernetes or different capabilities of Kubernetes in very small bite-sized videos. And it's very, very helpful. I highly recommend anybody who starts learning Kubernetes to go through this. And the source code for whatever I showed is already available on my GitHub repo. This is the link for that. And the slides that I showed will be available shortly on these two, the slide share as well as speaker deck. With that, I've almost done with my presentation. In case you joined in late, my name is Nilesh Gule. The combination of my first name and second name is quite unique. You can find me on any of the social media with this combination. So anywhere on LinkedIn, Twitter, GitHub, YouTube, it's the same, except for my blog, which is Hands-on Architect. Feel free to connect with me if you have any questions, any suggestions. I'm available on Twitter and LinkedIn. I would be happy to know your feedback. Any questions?
First of all, Nilesh, that was really awesome session by you, and like at last you shared all the learning resources as well, so that will really help all the audiences to learn more about KEDA. And yeah, so actually there are so many questions in between. So since we are also like running a bit of late of time, so I'll just take one question.
Okay.
So participants, if you have any questions, you can still post in the comment box, and Nilesh will try to answer them offline. So Nilesh, like as of now, there are no specific questions for you. So
Okay.
I will share the YouTube link with you so that you can go offline and hop in and answer the questions.
Sure.
That was really great of having you as a speaker today, Nilesh. Like we also hope that we'll be having you in our upcoming future events as well.
Yeah, it was my pleasure presenting for this wonderful event. Thank you. Thank you for this opportunity. And
Thank
I
you so
hope all the attendees, they learn quite a lot. It's a great
yeah,
event.
yeah.
Thanks.
Thank you so much. All right, guys. So that was Nilesh Gule, and his presentation slide deck will be available on the GitHub repo, and the link is there already on the comment box. Still, we'll be posting it again on the comment box for you guys. So before that, I'll just like to mention about the Azure Dev Challenge, since we have been receiving so many tweets on Twitter. So just in case people are not aware of the like steps how to achieve the Azure Hero Badge. So first you need to complete any of the learning paths and then make a tweet on social media, Twitter, along with the hashtag OSS days, along with your learning badge, that MS profile, and also your achievement badge. So only if you have already like tagged all these things, will be able to give you the Azure Hero badge. And for the detailed description for the rules and the steps, you can find them on the website. So thank you. So next we have Rajat and Vineela. I'll just quickly introduce them on the stage. Hello Rajat. Hello Vineela.
Hello.
Hey, how are you?
How are you guys doing?
Good, good. How about you?
Good.
I'm good. We are really excited to have you guys on stage and for the conference today. Before you guys, we had Nilesh as the first speaker for the afternoon session. So now we have both of you. So going further, can you both give a quick introduction about yourself, like what you guys are doing and what your session is going to be today?
Yeah, all right. So I'm Rajat. I'm working with Huawei. I work for the Soda Foundation. So in Soda Foundation, we are trying to solve day-to-day data challenges, and this is what we are going to present and talk to you about.
Awesome. So yeah, Vineela, would you like to go next?
Yeah. Hi, I'm Vineela. I'm from Huawei. I'm working in Soda Foundation. Yeah.
Awesome. So, Rajat, I see your presentation, so I'll put it on the screen and you both can go.
Yeah, sure.
Sure. So, it's live.
Yes, yes, uh, yeah, so hello everyone. It's exciting to be here and share uh, the story of data and data management with you all today. So ever since the beginning of humanity, we have been generating data in various uh, sizes, forms, um, varieties and velocity of data. And earlier we started with writing on the caves. So that was also one form of data, to bookkeeping and accounting and ledgers. And now we have data in ones and zeros. That is the bits that we have. So we have come a long way in the way we generate data, and so has the data management platforms also evolved over time. So today, let's see how the challenges of data management have been solved by some of the emerging platforms like Soda. So I'm Rajat, and I'll be taking you through the journey of data ever since the beginning of humanity. All right, so let's see what exactly Soda is. So Soda basically is an emerging platform for data management. So Soda was a recent introduction in the Linux Foundation in the early 2019, and it aims to establish open and unified and autonomous data management framework for data mobility from the edge to the core to the cloud. So Soda in itself stands for Soda Open Data Autonomy, which is a kind of a recursive acronym. It's open source and unified data autonomous data framework for data mobility from edge to core to cloud. And then the Soda Foundation offers a neutral form of cross-platform collaborations and integrations, and provides end users a quality end-to-end solutions. The Soda brings together industry leaders to collaborate on building a common framework to promote data standardization and best practices for data storage, protection, governance, analytics, and so on. To support data emerging from IoT, big data, machine learning, and other applications. So Soda is an emerging platform, and it has multiple moving parts. And let me try to simplify the Soda architecture for you. So as I said, like it's a framework. So looking at the picture on the right side, you can see the simplified overview of the Soda framework architecture. So we start all the way from the bottom, wherein we have various heterogeneous storage providers who have their own storage entities ranging from arrays to tape drives to SCSI disks and so on. So all these storage entities form the storage backend, all of which are heterogeneous and have different capabilities. So the challenge of managing and bringing all of them to this common platform is immense. That was the thought behind coming up with this Soda framework. So there are various pieces to solving this data puzzle that we have. So once the storage backends are provided, they dock onto the Soda platform via the dock service, which we see at the bottom. So the dock service is basically nothing but we have vendor drivers for each of the vendors, which pulls in the data from the various storage backends and brings them onto the Soda platform. And once we have the various data for the disparate vendors that we have, we are able to manage the data that emerges from these storage backends via the components like the controller, API, and NBP plugins, which we will see in a short while what they are. So once the data is available within the purview of Soda, we are in a better position to manage these data and present them to any user on the via the dashboard that we have for Soda. So the core pieces of the framework are the controller. Once the data is within the Soda's purview, controller plays a critical role for all the API flow management. Suppose any operation that has to be done on the data that we have collected from the API or the dashboard, all the calls go through the controller. Then there is the standardized API layer, which basically does the job of standardizing all the calls to various storage providers. So that all we need to do is call one API for any of the providers that we are trying to manage. Then we have the various plugins, the northbound plugins, which we call. They are focused to extend all the industry platforms and application solutions to interface with SODA API or be compliant with them. Then multi-cloud also is a very core piece of the SODA platform, which we'll see in more detail as we go through the session. So multi-cloud, in summary, it basically tries to provide cloud vendor agnostic data management for hybrid cloud, cross-cloud, or inter-cloud. It can be hosted on-prem or on cloud native as well. Then there are the sidekicks like the telemetry, orchestration, and SODA intelligence. So as they provide the telemetry provides basically all the statistics and health data from the infrastructure, and this gives a better hold of the infrastructure that users are trying to manage. And then we have the orchestration. Orchestration framework basically provides flexibility to user to use existing workflows or define customized workflows to get the simplified execution of tasks. Then as we talk, intelligence is one piece which is coming up rapidly. So once we have all the data collected from the various backends, we provide intelligence on top of them using some of the ML algorithms. Okay, so these are the various moving parts within the SODA framework, which provide all the capabilities that SODA has to offer to the users. So let's focus on the multi-cloud, keeping in mind the theme that we have for today's talks. So multi-cloud, exactly what exactly is the multi-cloud? So multi-cloud, when we speak about multi-cloud, it's basically basically it makes use of two or more cloud computing services from any number of different cloud vendors that we have. So multi-cloud functions can span across all private, all public, or it can be a combination of both. So why exactly multi-cloud? Why even given that cloud in itself is a pretty complex solution to consume, what was the need for multi-cloud? Okay, so there are quite a few needs when we think about multi-cloud. So given that we have multi-cloud was kind of born out of competition. So from the business point of view, when we have multiple products, we always want to take the best advantage of by the price arbitrage between those two products. So price arbitrage happens to be one of the reasons for using multi-cloud. So given a particular feature, for example, storage itself, so there can be pretty decent amount of price arbitrage between various providers like AWS or Azure or Huawei or so on. So we want, as the users, we want to make the best of the price arbitrage, and so multi-cloud. The reason for multi-cloud. Then there are various services. For example, there may be specialized services which may be being offered by some of the vendors, which the other vendors may not have been caught up to. So we want to be the first users of some of the specialized services which have recently been launched. So, but given that our data is on cloud A and the services are on cloud B, so how do we make use of the latest services which have come on cloud B? So again, multi-cloud is the answer. Now that we are storing all the data, suppose on cloud A, and we, for some reason, the policies have changed or some of the pricing have changed. So we want to avoid that kind of a situation where the user is always being governed by the vendor. So we want to avoid that vendor lock-in kind of a situation. So again, multi-cloud is the answer. Clouds, for example, they may be having an off day. So we have seen that in the recent past, some of the clouds were down for a few of ranging from few minutes to hours to days. Cloud is essentially a service which needs to be running up 24/7, 365 days a year. So we do not want to have be caught off guard wherein clouds are having an off day and we are not able to access our data or the services which are hosted on the cloud. To overcome this situation, again, multi-cloud is the solution. Then going forward, backup and disaster avoidance, which is again a spin-off from clouds having an off day. Again, then there can be various business scenarios wherein acquisitions have happened. Cloud A has acquired Cloud B, and there can be a merger or there can be shutdowns in some of the cases. So we don't want to be left off guard, and we want to have our data to ourselves. And so for that reason, we need to have a solution which is beyond a single cloud. Then there are various policies like government policies like GDPR and so on, which force us to have data presence within the region that we are operating in. Then, of course, the customer is the king. So the choice of the customer always matters. So the customer may choose Cloud A plus Cloud B, or maybe Cloud A plus Cloud C. So again, multi-cloud is prevalent there as well. And there are finally some typical use cases which require us to have data presence on more than one cloud, just for the reason that one of the clouds may go down anytime. Example being some typical applications like pager duty or some alerts which we don't want to miss, and then the other reasons which I spoke about, like the GDPR policies. So that also requires us to store the data in the region that we are operating in. So these are the some of the reasons which came to top of my head to talk about. So these are the compelling reasons which forces us to look at the multi-cloud aspects of storing data as well. So how do we do it? So simple answer is use Soda. Okay, so now again, let's look at the architecture from the perspective of multi-cloud. So we built this framework, but how exactly multi-cloud fits into it? So multi-cloud basically provides a vendor-agnostic data management for hybrid inter or intra-cloud. The features that we have so far basically support S3 and S3-like compatible backend managers, which enable to connect to any of the cloud vendors. So far, we have been able to support cloud backends like Azure, GCP, AWS, Huawei, IBM, and so on. Some of the important features which we have so far in the multi-cloud are policy-based data mobility across public and private clouds. And it provides object, file, and block services from the cloud vendors which we support. So let's see how. So this we already talked about. All right. So this is a simplistic architecture of the multi-cloud that we have implemented in Soda framework so far. At the bottom, we have the various cloud providers. And so once we want to use a particular cloud, we should be able to register that particular cloud with the Soda framework, which happens via the backend adapters. So once the backend is registered with Soda framework, we are able to perform any operation on those backends from the APIs and UI of multi-cloud. from Soda. So some of the important features which are there in the service layer are the S3 service, basically the object service, the file, block, backend, data flow service, data mover service, and so on. So these services enable us to manage data within a cloud, inter-cloud, and intra-cloud as well. So these features are all exposed through the API layer to the Soda dashboard or any other REST clients that we have. And identity management is provided through Keystone, which is a well-known identity management component from OpenStack. And so next, so these are the features which we discussed about, and we'll be seeing a short demo on data migration, which will kind of cover all the data capabilities, data movement capabilities of Soda, and that will be interesting watch from Vineela, who will be presenting that. So going a little bit more detail about each of the services that we have on multi-cloud. So basically, everything starts with a backend manager. So backend manager is a kind of a registry for each of the cloud vendors within the to Soda. So whenever we want to perform any operation on any of the clouds we support, we need to first register that cloud with Soda. So backend manager is the component which does that. So it supports create, update, delete for any particular backend which we want to operate on. So it also serves as the metadata placeholder for any of the cloud backend profiles that we are trying to support. Yeah, similarly, the S3 service. So S3 service again, it works in conjunction with the backend adapter. So S3 controller basically serves as a bucket and object metadata placeholder. So a bucket in Soda multi-cloud is a virtual bucket. It's so we have the physical buckets in each of the clouds, but Soda multi-cloud provides a virtual bucket that maps to the physical bucket in the object store on premise or in the cloud. So whenever any operations related to the bucket, like create bucket or post an object on a bucket, those kind of operations are performed. So we get the location of the bucket through the location mapper, and then perform the operation using that location. So in the demo, we'll see how all of this is done. Similarly, any file operations which need to be performed is done via the file service controller. Again, it gets the backend service, and any search operations are provided by the backend service. And then any physical operations to be done on the file service is done on after we get the file location. And then so these are kind of a template kind of operations which are done across the object, the file, block, and object storage. And similarly, we have the block service. Here, the cloud volumes and the block devices management support is provided. The block service controller serves as the metadata placeholder for cloud volume resources. So we are able to search the backend service where we get the backend, and we perform the block operations on those backends. And data flow service. So data flow basically comprises of two parts. One is the data migration and replication. So right now we'll focus on the data migration for the demo and description. So the data flow manager is comprised of basically the policy manager, connector manager, plan manager, and the job manager. So whenever you want to do a data migration from Soda, we can define policies on what kind of policy we want to run on a particular data migration. Whether we want to schedule it for like a daily basis or a weekly basis or monthly and so on. And also we have the plan manager, wherein we want to say that the plan is to be run automated at a particular point at a particular time of a day, week, month, or so on. So that's when the data migration is kicked off, and job manager handles the migration job while it is executing. Connector manager is a vital component here, which basically establishes the connection between the clouds for data migration between the clouds and so on. So then we have the migration job execution to data mover through Apache Kafka. It's a distributed streaming platform, as you know. And data mover has different plugins to handle different migration tasks. So these plugins are developed as and when we are supporting various clouds. So let's see how this data migration works. So the first step to data migration is we create objects. We create, first of all, the bucket needs to be created. And then we place the upload the objects into that bucket. Then we want to migrate the bucket, migrate the objects from cloud A, which is AWS in this case, to cloud B, which is Azure. And then, yeah, so we can migrate the data across the clouds. So some of the supported storages are AWS S3, Azure Blob, Huawei, Alibaba, OSS, Chef, IBM, GCP, and VB. So user can migrate data immediately, or they can schedule it for a later point in time. We will see in the demo how. Then user have an option to delete the objects once the data has been migrated successfully from the source to destination. So here we can see that we have given the delete from source to true. So once the data migration is done, the data from the source, which is bucket AWS, is deleted, and if it is false, data is present on both of the source and destination after the migration. Okay, so next up we have a short demo from Vineela, and she'll talk you through the various steps which we perform on Soda dashboard for migration. So Vineela, over to you.
Hi everybody. To process the data migration, we need to first register a storage backend. To do that, we give a name of the backend. We select the type of the backend, AWS S3. We'll give credentials like region, endpoint, bucket name, access key, secret key. That way we can register. I have already registered. This is AWS backend. We have also Azure backends registered. Now we will create buckets on the registered backends. To create buckets, click on the create. Give the name of the bucket. Type of the bucket, AWS S3. Backend needs to be selected. We can enable encryption. Okay. Bucket is created successfully. We will create Azure bucket now. Type is selected as Azure storage. Select. Okay. It is successfully created. Now we will upload files. Upload. Select any random file. The file is uploading. Successful. Now we will upload another file. Select file. Okay. It's uploading. Successful. We'll go to the Azure. We'll go to the console. AWS console. The files uploaded can be seen here in the bucket. We'll go to Azure bucket. No records are found here. Now we do the migration. Go to data flow. We'll create a migration plan. Create. Give the plan name. Source bucket is AWS. Demo AWS. Destination bucket is Azure. We can do immediately. We'll delete the object after it is migrated. Okay. Now we'll see what's happening. Process is going on. Success. Our migration is done. Let's check. We go to buckets. Azure bucket. The files are uploaded here. AWS bucket. They are deleted after migration. If we refresh, the files are deleted in the AWS. We'll check in Azure. Demo Azure. The files are. Our migration is successful. The time can also be seen here. Yes,
All right.
thank you.
Yeah, so that was a really quick and good demo from Vineela regarding the data migration between two clouds. But right now what we demoed was migration of small amount of data from AWS to Azure. So always it's not so simple. Data migration has its own challenges. For example, when we are trying to migrate a huge amount of data, say 1 TB of data between AWS to Azure, so it has its own challenges. There are session timeouts, there are network outages, and various challenges. So Soda as a platform is trying to address those challenges, and let's see how we can do that. So we have been into production only a couple of releases now. Soda is still in the infancy. So, but then it will soon mature to solve such big and important challenges regarding data. Okay, so with that we come to the various object lifecycle features which Soda provides. The data that we have is not always useful, and sometimes we tend to discard the old data which is not in use. So Soda provides automated capabilities for moving the data across tiers. If the data is frequently used, we keep it in tier 1. So tier 1 basically maps to standard for AWS, hot for Azure, and again standard for Huawei. But if the data is not so frequently used, then we move it to a cheaper and cheaper kind of a storage, which is basically tier 99. So tier 99 maps to standard AI for AWS, cool for Azure, and warm for Huawei. So as we can see, the naming convention between clouds is different. So to give a common name for the various storage tiers, we have come up with a terminology of our own. And finally, we have the tier 999, where the data is in no more use, but we need to preserve the data for due to certain policy compliances. So which AWS does well by Glacier, and Azure by archives, and Huawei by cold storages. So we can provision, we can have these kind of policies on data, wherein once the data goes out of use for say a certain amount of time, maybe say 30 days, we move it to from tier 1 to tier 99. And say if it is no more in use for next 60 days, we move it from 99 to 999. So that is what we have tried to depict here in the slide. So once the data is out of use for say 90 days, then we purge the data. So this kind of policies are applicable within cloud and intra cloud as well. For example, suppose Azure provides a cheaper storage of data beyond 30 days. So we move that once the data is no more in use in AWS, we move the data from AWS to Azure for tier 9999, and thereafter, if it is no more in use for the next 60 days, then we go ahead and purge it. So
sorry to interrupt you, Rajat. We are actually just a bit out of time. So
yeah. So I'm done. This is the last
sure.
So as we seen, this is the kind of data story which we have built for managing disparate data across distributed environments. So hope you liked it and learned something new here. And with that, I come to the end of the session. So I urge you guys to explore Soda and come and join us and help solve data problems in much better way. Thank you. Thanks a lot.
Awesome. Thanks a lot, Rajat and Vineela, for your presentation and the demonstration. Hope all the participants enjoyed it. And so also participants, for the information, like we'll be sharing the presentation slide of Rajat and Vineela in the post-event later. So Rajat and Vineela, there are no specific questions as of now in the comment box. But anyway, we'll be sharing the YouTube live URL with both of you guys so that you can hop into the comment section and answer if there are any questions offline. So thanks a lot to both of you for joining us today and sharing your experiences on data migration.
Thank you. Thanks a lot. It was a pleasure talking to you.
Okay. Thanks a lot. Okay, so guys, that was Rajat and Vineela from Soda Foundation, and next we have Ashirvad. So since we are running a bit of late, so I won't go into the agenda again. So after Ashirvad, we have our last session from Shubhangi. So I'll just quickly introduce about Ashirvad. Hello, Ashirvad.
Hi, Rohit. Hope you're doing well. Good afternoon.
Yeah, I'm doing well. How are you doing?
I'm doing good too. Thank you.
Awesome. So, we are really glad to have you, Ashirvad, today for the conference. And this is the afternoon session's third talk, which is by you. So, Could you please give a quick introduction about your role, like what you're doing and what your session is going to be? Meanwhile, I'll share the screen.
Yeah, sure. You can share my screen. I have a introduction there. So I'll
Awesome.
start off. Okay. So the topic
Sure.
for my talk would be refactor .NET Core Web APIs to serverless APIs using Azure Functions. Okay. So before getting into the talk more, I'll give a brief introduction about myself. I'm Ashirwad. I work as an associate software developer at ESSPL. I'm a C# Corner MVP. I'm a cloud enthusiast. I work around many cloud solutions, whether it is Azure, IBM Cloud, or else AWS. Most of my development work are related to ASP.NET and ASP.NET Core. I'm also an UiPath certified RPA developer. And if you want to contact me, these are the links where you can connect with me. And if you have any queries, if you run out of time, you can definitely check in with me over there. Okay. So moving into the agenda, we'll start by discussing what is API. Then we'll move around how can we make one. And post that, we'll have a look about evolution of application hosting platform. And then what is serverless. Then we'll go around Azure functions. Then we'll have a problem statement which we'll try to solve. Actually, I have an API which solve this problem. We'll try to refactor it and make it serverless. And post that. That's all. And finally, we'll publish the API that we made using Azure function in Azure, and I'll make the link available for you people to test around. So what is an API? As the picture depicts over here, an API is just acts as an interface between a client and a server, or else it acts as a middleman which takes your request, processes it by giving it to the server to process it, and gets back your response. So it's just a simple interface, right? Okay. So how can we make one? Now we know what is an API. So how can we make one? You can use an web API using .NET's web API framework. If you're in Python, you can use Django or Flash to make one. Suppose you're a JavaScript developer. Then you can use Express.js and Node.js to do that. Same with Spring for Java. Okay. So next, the evolution of application hosting platform. This is a brief to tell you about how the whole thing started and how we reached a serverless. So back in the days, we had things like on-prem. I have this analogy using which I explain this whole thing, how we went from on-prem to serverless right now. So back in the days when companies actually had the whole servers, they used to buy servers, they used to have these storage devices, networking setups, everything to be done by their own team. So it was really painful. So it's moreover like I got a job in Bangalore. Suppose right now I'm based in Bhubaneswar. So I got a job in Bangalore. The analogy is more like when I go to Bangalore, I buy a house just to stay there and work from there. So that was more like an on-prem thing. You buy everything to host an application. But as things changed and the years moved on, something new came to the market. It was IaaS, infrastructure as a service. So what happened here is that now you don't need to buy in the servers. Now you don't need to buy the storage devices to host your applications. So it's more like instead of buying a house in Bangalore, you can just rent one and just pay for the time you're being there and just use it. Now you're completely safe from all the property taxes that you would have to pay if you were to buy a mansion. The same with the on-prem servers and storage devices which you bought and now they are outdated. You don't even need to be bothered about the cost of that because you're just renting it from someone else's system, right? Your cloud providers are more like the person who rent these resources to you. Next is PaaS. So PaaS is more like renting a small flat or an apartment in Bangalore instead of going for a house. So now you're safe from the hassles of actually patching the operating system in PaaS. You don't even need to be bothered about the storage capacity or else a lot of the things. So this was a way. And PaaS normally solves almost most of the problems that normally when you try to move from an on-prem to the cloud or you have a cloud native architecture. If you move on, then PaaS is more sufficient. But there are certain things that PaaS even didn't used to do. It was more like you need to have to write rules for upscaling or downscaling your applications. You need to do that because suppose these days Amazon and Flipkart, they have the Great Indian Festival or Big Billion Day sales, right? At the time they have huge spikes in the traffic that they normally get on their website. So at the time they need to scale up. So you cannot manually just scale it because you cannot pick it right time when the spike would go up, right? So it's more of like you need to have this auto scaling rules you need to write, or else you need to have some what we say, you need to manually upscale it or downscale it whenever the traffic goes up or goes down. So this was a problem which even PaaS had. So to overcome this particular thing, we went into serverless. So serverless is more like renting a room in Oyo. You don't even need to have an agreement that you used to have with your house owner when you rent a flat. You don't even need to pay an upfront cost or anything. So the number of days you stay, you just pay for the money for that, and that is moreover serverless. The amount of resources you consume, or else the time your application actually runs, you only pay for that. You don't even need to pay when your application is not running. When it is when there is a downtime and suppose your application is not being used at all, then why should you pay money, right? So this is moreover like serverless, and this is how serverless came into the picture. Okay, so what is serverless? So there are multiple components which are normally associated with a serverless architecture. So one of them is stateless. The state of the application never stays inside the server. So once an execution is done, all the data that was associated with that particular execution is lost. You're not going to get that back. It's not going to be persistent. It is event driven. This is another thing that is always associated with the serverless architecture. So event driven is moreover like there is an event which triggers your application to run, and this is how the whole application works. Suppose somebody knocks your door, you open it. Unless somebody knocks it, you're not going to open the door, right? So it's moreover like that. Next is micro billing. You only pay for the time your application is actually running. So if your application is running for a second, you only pay for the second, not more than that. So abstraction of servers. This is what serverless actually is. It's an abstraction of infrastructure management. So this is the essence of an serverless architecture. Okay, so what is Azure Function? Azure Function associates all those things that are associated with a normal serverless architecture or an application made using serverless architecture. So this is a serverless offering offered by Azure. So apart from the four things which we discussed in the previous slide, one more thing comes into the picture in this slide is function as a service. Azure Function is a function as a service offering of Azure. So in this, you can write function as a service, which is normally a chunk of code which you can execute whenever a particular event happens. And after the event, is done, is successfully executed, your function goes back to sleep or it's in an idle state. Okay, so that was more about Azure Functions. So since the topic was more about refactoring and .NET Core API to a serverless API using Azure Function, we will not get deeper into what Azure Function is and what triggers and bindings are here. So let's get into how can we make one. How can we make an Azure Function? So there are multiple ways of making one. You can make one using Azure Portal itself. You can make one using Azure CLI. You can make one using Visual Studio Code. Okay, so apart from that, even if you use any other IDE like Atom, Sublime, you can also make that, provided you have the function runtime tool. So you need to install that, and after that you're good to go. You can absolutely write one using any other tool. Okay, so let's make one using Azure Portal. So let's go to let's go to okay, this is my Azure Portal. I have logged in. So let's create a function app. So inside of function app, all our Azure functions are there. This will be a quick demo on how to create an Azure function using Azure Portal. So post that, we'll have a look at the problem statement. Since I thought many of you may not be knowing, that's why I'm giving a demo on that, and it's good to know. So as the resource, let the resource will be the same. Test demo. select it as okay. So here you can see that Azure Function supports a lot of languages. You can write one in Node, .NET Core, Node.js, Python, Java, PowerShell. You can also write one in TypeScript. So I'm selecting the runtime stack here as .NET Core. The version is good. Let's select as US East uses East US. Okay, it's the hosting. So while going through, we can discuss normally the things that are associated with Azure Function. So you need a storage account because though your Azure Function is a serverless offering, but still it needs to store its data somewhere to process it or to execute it. So we'll have a storage account associated with an Azure Function, but it completely depends upon you. If you have an existing storage account, you can also use it with your function app to run your Azure functions. I need not bother about this. Okay, let's click on review and create. Let's wait a while. Okay, it's done. Let's create. So this is how easy it is to create a function app in Azure portal. So once it is created, we'll go inside portal and create an Azure function and test it. Okay, it should take some seconds to complete. It should take a longer time. Okay, should be done in a minute. Okay, so since it is taking some time, I'll say about a few terms which you need to be familiar about while working with Azure Function. So one is the trigger and the other is a binding. So trigger is something which invokes your Azure Function to run. Triggers can be anything in Azure Function. There are multiple triggers and bindings available. So some of the triggers are HTTP trigger. There can be a blob trigger or a Cosmos DB trigger. And if you want to know the supported bindings and the triggers which are supported, then you can have a look over here. This is the link. You can use this link to check it out. And okay, there are some what we say, some offerings which works with the function runtime 1 and doesn't work with 2 or 3. So here you can find all the details, and you can just have a look over here in the documentation part of Azure Functions. Okay, so it should be deployed by now. Okay, so now it is deployed. Let's go to the resource. Okay, to create a function, you need to go over here, click on the function. Now you need to add one. Just a minute. Okay, click on add. Now we are creating an Azure function. Function app is nothing but a logical grouping of your Azure function. Now, if you need to select the development environment here, if you if you select the development environment as VS Code or any other editor, then you cannot make any changes over here. You cannot make you cannot write anything over in the portal. So I have selected the template as HTTP trigger. So whenever our function gets an HTTP request, then it's going to be invoked and it's going to run. So Azure function is ready. So our template is ready and good to go. Let's click over code and test to see it. It's taking some time. Let's wait. Okay, it's loading. Let's wait a bit. Okay, so this is the template that we got. Let me describe you a bit about this function. So it's taking an HTTP request object, that is right, and we are trying to gather we are trying to see whether any value was passed in the query string or else in the request body. If it was, then it is trying to find it out and store it in the variable name. If something was passed in request body, it is trying to deserialize it and then store the value over there. And once you get the name, then it is just checking whether it is null or empty. If it is null or empty, then it's going to say the HTTP triggered functions executed successfully, but a name was not passed. If it passed, it's going to say hello message. You can test it out. Just take the URL. You can directly do it over here. Name. Sure what. Yeah. Okay, just a minute. Okay, let's test and run it. Okay, it fired over here, as you can see. You can test it out here as well as over there, but due to some reason it wasn't working. So let's check it out. Okay, that's all about the demo in Azure portal. Let's go back to the slides. Okay, so let's go to the problem statement. So the problem statement is moreover like you're working at an organization, India Inc. Incorporated, and of late your organization has been able to retain many of its existing customers. Was not able, not able to retain many of its existing customers. To understand this, you're sharing a feedback form with your customers to share their experience with your organization. Now the management wants to receive all the negative feedback shared by the customer to address this concern and work on them. It's more like you're losing your clients, but you don't know why. So you're sending forms so that you can know what is the reason because of which they are leaving us. Maybe they are not satisfied with the product, so you're asking them to give their feedback about a particular product, and if they're giving negative feedback about the product, you need to inform the management about it. So I have designed an API which does that. So it takes the feedback from the customers. It does sentiment analysis on that using Azure Text Analytics. It's trying to find out the sentiment score about that. If it is positive, then it sends what we say. It sends a mail to the customer that we are glad to have you or something like that. But if they're unhappy, then you say that we regret for the experience you had and we'll try to improve more, as well as share the feedback that the customer shared with us through the form to the management. You need to mail that particular feedback to the management. So this is the thing that we want to do. So how do we do that? Let's have a look at the API. Okay, so this is basically the API. There are just two methods over here: get feedback, submit feedback. So let's start with submit. I'll be using Postman to send the request. So I have Postman over here. I'm going to submit one. So let's start our API. We have some breakpoint because we wanted to know how the flow actually happens. Then we'll see how can we refactor the same. Then how can we refactor the same API to a serverless API using Azure Functions. Since at this start, I'm going to go to Postman. Just going to do some modifications over there. Okay, since I have already given this data, I don't want to put it out. Let's use Rohit's name. But the mail ID be the same. Product ID. Okay, let's keep it as OSS stays. Product. Let's say that the conference is a product for the time being and the product ID be 3 or something like that. And let's check. Okay, it's running. So let's send the request. Okay. Just inform. Just a moment. Let me try it back. Sometimes things happen in the demonstration when you make it. You often don't. Okay, Git feedback seems to be working. So let's try again. What's happening? Okay. Okay, so it did hit a breakpoint and finally it's working. Thank God. So let's get into the business of the application. You can see we're trying to find out the feedback rating of the feedback that the customer had given on the particular product. So let's get deeper into it. Let's see what it is. It's a very simple thing. I'm just consuming the text analytics SDK of Azure to do the sentiment analysis over there. So I'm passing in the feedback. I'm trying to get whether the feedback was positive or negative. So okay, let's see what it was. The sentiment was okay. We'll see it in the next slide. Okay, so okay, let's see the feedback rating. It was positive. That's good. Now we need to send a mail, right? So let's look at the email helper class, what we have written here. If the feedback is negative, then you need to send a mail to the client as well as one to the management. So since this time it was positive, we are only going to send the client that thank you for your feedback. So I hope it's done. Now you're going to insert this record to our DB. This is an Azure SQL database, and if you go into it, it's a very very simple Edureka code that I've written over here. You can use entity framework. I just wrote it to make the demonstration pretty simple, to be honest. Not everyone is aware of ORMs. So one record was inserted. We can just hover over here and see. One was inserted. Now we are going to return the feedback, and let's click on continue and see what we get. Okay, we got the same thing. We can now go over here and check it out. Previously there were 3 records, now there should be 3. 2 records, now there should be 3. Okay, great. So this was the simple thing. This is a very simple API that we made over here. Okay, so these are these are what we say. I have a business layer, there's a DAL, there's a model, there's a utility class, and there's the API. So while converting this particular API to a serverless API, do I need to create all of these things again, write the business again, write the DAL again, write the model again, or the utility again? No. The answer is simply no. It's pretty simple. So how do we do that? So to do that, what we need to do is this. Let's open Visual Studio. I'm going to run it as an administrator. Click on run. We'll be adding the DLLs of this particular APIs, the business layer or the DAL, as well as the utility and the model to use, so that we can do code reusability. So let's wait a bit. It's taking a bit longer. So once the templates are loaded, we'll go with the Azure function template. You can also find it over here. When you go to cloud, then you can see Azure function, but you need to have the workload of what do you say, Azure SDK installed in the you can do it in the Visual Studio installer. While doing that, you need to install that particular workload, and it's good to go. Let's name it as OSS days serverless API demo. Let's create one. Okay, you can see there are so many triggers available, which can invoke our particular Azure function. But we are interested with an HTTP trigger because we are trying to make a simple API. So let's keep it anonymous. Authorization level as anonymous, because we don't need to, we don't want to actually pass in a master key or else a key for a function to, check if the user is actually authorized to use it or not. But later, if you're working in a production environment, then these things comes into picture. But since it's a simple demo, I'm just gonna go with the anonymous part. Okay. Okay, let's wait a bit. Let's call and install some of the dependencies. We can see some swigglies or not. It's restoring the packages. Don't worry about this red swigglies. It's gonna go in a while once all the packages are installed. Okay, that's great. So for each API, for each action method we had inside our API controller, As you can see over here, we had one action method for get feedback and another for submit feedback. So each of them are gonna be separate functions. So let's change the function. If you want to change the function name, you can rename it over here, but renaming it over here doesn't make any changes, to be honest. Let's keep it as get feedbacks. Okay. But still the function name wouldn't change. You need to modify it over here in this particular attribute. Now since it is a get request, we are just gonna get it. We don't need we shouldn't allow a post request to be made over here. If somebody makes it, then you're gonna say it as a bad request. Okay, the authorization level is anonymous. You can use this particular attribute to customize the route of your function. For the time being, we're not much concerned about that. Okay, we don't need any of these things for the time being. For this particular API, we don't need any of these things. So let's clear all this. Skip it as empty. Now, how can we reuse the, the business layer or whatever we had written over there? Let's go over browse. We are gonna add all those DLLs. Go to desktop in the new folder. I have my APIs. Okay, so let's go to business. Then the bin debug standard. Okay, I'm gonna select all of these DLLs. I'm gonna add them this particular application. But these DLLs or these projects have some dependencies. These dependencies can be like I need to install data.sql client for the DAL. Similarly, for utility, I was using SendGrid to send a mail, and using Azure Text Analytics to do the sentiment analysis. So I need to install those even over here. So you can do that by using the Nugget package manager and just install them. So I have used Newtonsoft. So okay. So since I had used Newtonsoft, I need to install it over here. Next, data.sql client. Okay, the system.data.sql client. I need to install that for my DAL to function properly. Okay, so these things are installed. So we are good to go to write our first serverless API or refactor our first serverless API. So right now what we need to do is that feedback business. Okay, what was the name over here? Feedback business, right? We need to create an instance of feedback business class over here. Sorry. Okay, so now you need to call the particular library using OSS days business. You can see that our project name, the business layer's name was OSS days.business. So I have used that. Right now what I need to do is data. I'm gonna store the feedback that I get. Then I'll call this particular method get feedbacks. Okay, once you get that, since it's gonna give me an JSON string, I'm gonna pass in the value over here, and let's run it. So this is how simple it is to refactor an existing API to a serverless API. Though I am creating an instance over here, dependency injection is supported in Azure Function, but since it was a bit out of scope of this particular demo and it would have taken a longer learning curve, that's why I haven't included over here. I try to keep it simple, but you can absolutely do it. It is supported from Azure Function Runtime 2.0 and 3.0. It is not supported in 1.0 if you're using that. So let's run it and start our Azure Function code runtime tool. Meanwhile, when I start, I'm gonna just check whether I got the mail or not, right? As you can see, I got the mail. Thank you for the feedback, which I had previously done in Postman, right? I sent a request that this was a really good product, and according to our business, it sent me a mail that, thank you for feedback, since it was positive. Okay, now the function runtime tool has started. So let's wait a while it gives us the endpoint. So the endpoint is, okay, HTTP localhost server. So, okay. HTTP localhost API/get feedbacks. And see whether we get 3 records or not. You get it. So the first part is done. One API is done. So you just need to add the DLLs, and that's all you had to do to get to convert your API, a normal .NET Core API, to a serverless API. So let's stop our function runtime tool. As we are short of time, I have already made a demo for that. So I'm gonna show you this particular thing, like how we converted the whole .NET Core API. Like we had 2 action methods inside our API controller. One was for get feedback and the other was to submit feedback. So I've written both of them over here. I have added the Nugget packages, the Azure AI Text Analytics, Microsoft, the .NET SDK function is something that is required while making an .NET function, Azure .NET function. Then Newtonsoft JSON, which I used to deserialize, and SendGrid to send a mail, then the system.data.sql client to interact with our Azure SQL. So it's really easy even to debug our Azure functions locally before deploying them. So let's run this one and try the submit feedback again. And let's debug it. I have kept a breakpoint over here. So let's wait a while it starts. And once it is done, we'll start the deployment process. We'll publish it in our Azure account. So once we get the endpoint, we're gonna go back to Postman, our pretty own helping tool. So we'll use that and test, and how easy it is to debug your Azure functions. Okay, I'll just go back to the browser, grab the URL. Paste it over here. Instead of get feedbacks, we're gonna do submit feedback. Pathetic. Okay, this was a really bad product. Let's say Copcat, something like that. Okay, let's submit it. Let's send it. Let's change the product ID to, else we can have a conflict. Okay, our debugger did hit our breakpoint. Let's click on F10 and see what the request body got. So over here, okay, so it got here. So now we're gonna deserialize the object. We created an instance of our business layer. Now you can see the data. It got deserialized. It got all the value. The feedback rating it didn't had because we are gonna get it from the inside our business. So let's click F11 to go inside of it. You can see the same process which I had showed you back. Here we are trying to find out the sentiment score or else the sentiment of our particular feedback, whether it is positive or negative. So you see it's negative. Then the rest of the things you saw how it goes. So yeah, now we are sending a mail. Once the mail is sent, Got the feedback. It's done. See the response. You're just gonna get the response of the data that you had shared with the feedback rating. The rating was negative. And let's click on continue. And see the response. We saw the response that we got. The feedback rating was negative. Let's go to my inbox and check whether I got another mail or not. I got a few more mails. See, since I was the admin over here, since I am the management over here, my ID was a management that I had explicitly mentioned in the what do we say inside the business. That's why I'm getting the feedback that this was a really bad product. And since I'm also the consumer over here, I also got the message that we regret for inconvenience. We'll try to improvise to make better experience for you. So that's all for the session. Let's publish this one and get it up and running. So to publish it, it's rather simple. It's not quite a rocket science, to be honest. Just click on publish. So once you click on publish, then click on start. Click on Azure. Azure Function App Windows. Function App is nothing but a logical grouping of your Azure functions. So, okay. I'm going to create new function, new Azure Function App to store our Azure function for this demo. Okay, let the name be same, no issues with this. OSS serverless APIs. Okay, this is my subscription. Okay, you can choose any of this plan. With consumption plan, there are normally some constraints, like you're going to face a cool start, so it's very minimal, but the first request that goes to your Azure function can have a cool start of a few seconds, but once it is running, then the cool start is nearly negligible. If you want your Azure functions to go up and running all the time, then you can use app service plan or else premium plan. So let's click on create.
I'm sorry to interrupt you, Ashipad, but we are
yes, right.
out of
We are out of, just give me 2 minutes.
Okay, sure.
Yeah, 2 minutes would be enough. Okay, let's create. Now we are creating some resources. So once all the resources are done, we're just gonna publish them, and it's just a few minutes work, and we'll be up and running. Okay, since we are creating resources right now, from inside our application, that's why it's taking a bit longer. But normally, if you have already, a function app and everything already created or provisioned inside your Azure portal, you're not going to face a longer time. Let's wait a few more seconds. Okay, it's done. Let's click on finish. Okay, should. Okay, let's click on publish. It should go. Meanwhile, the publish process is going on. I'm gonna show you where suppose you're not into .NET, you're using JavaScript, then you should definitely try this particular module, which is available on Microsoft Learn for free. You can use it to see how you can convert a Node.js or Express API to a serverless API with Azure function. This is something which prompted me with this particular talk. If you wanted to see all this code and try by your own, you can find it out in this particular repo. This is a public repo in my this is a public repository in my GitHub profile. You can check it over there. Let's see if it is okay, it's deploying. It did start deploying. Once it is done, I'm gonna share the link. Okay, once it is published, we'll just check the get feedback API that we had created over here, and that's all we are going to do for the time being. In case you have any other questions, you can contact me over LinkedIn, GitHub, or not on Git. Okay, you can post your questions in that particular repository in GitHub, or else you can connect with me over Twitter. No issues with that. I will definitely answer it over there. Okay. I'm really sorry, Rohit. It was taking a bit long time. So okay, so it is deployed. Let's go to our portal and check whether it's there or not. This is just demo. Okay. Somewhere. Okay. Oh, is it? Okay. Here we have our API. You can see there are two functions. It should be there. Okay. That's it. App is currently on read only. Okay, this should be the one. Okay, it normally takes some time to reflect. That's all from me, Rohit. Are there any more questions?
I'm just going through the comment box. So right now, are there any questions? No, actually, Ashiva, there are no specific questions regarding the session, but people are asking for the slides. So anyway, we are going to send the slide deck and the post-event mailer. So request you to share that after this session.
Yeah, absolutely. I'll do share that, and it's also available in the repository which I showed during the demonstration. They can take it up from there, or else I'll also share it with you. No issues with that. That's all from my end.
Awesome. Thank you so much, Ashira, for joining us today and sharing your experiences. And we look forward to having you in our future events as well. It was really awesome.
It was a pleasure. It was really a pleasure. Thank you. Have a good day.
Okay. So, guys, that was Ashirwad. With this, we have our next speaker, Shubhangi. So, I'll just put her on the stage. Hello, Shubhangi.
Hi, Rohit.
Hi. How are you doing?
I'm well. How about you?
I'm doing good. Apologize for the delay in the timings.
It's totally fine.
Okay. So, yeah. So, you are the last speaker for today's conference. So, now the stage is yours. And I would request you to give a quick introduction about yourself, like what you're doing and what your session is going to be today.
Yeah, sure. I do it along the session as I go. So
sure.
Thank you. Hi, everyone. Glad to be here. So this is the last session. I know that most of you would be low on energy. So let's see if you're awake and just drop what your favorite dish is in the chat, or where you're from, where you're joining from. Let's see if you're awake or not. Okay. No responses. All right. So anyway, I'll start by introducing myself. So I'm Shubhangi, and I've been part of many student developer communities for over 2 years. And I've been part of Google developer groups, WTN, Hack Club, and all that. Recently, I joined this community called, Puneet replied from Kolkata. Hi, Puneet. Hi, Amit. So please keep dropping that in the chat. Where are you from? Yeah, so I was telling about myself. So I joined this technical community called Microsoft Learn Student Ambassadors earlier, which was Microsoft Student Partners. And it was one of the very engaging technical communities that I've been a part of. you must have interacted with some of the MLSAs throughout the day and got to know about Azure or Microsoft Learn or other technologies that they have been telling you about. So I just wanted to know if you have ever attended a meetup or been part of any community events, or is this your first virtual meetup, or have you attended any in-person meetups? I wanted to keep it interactive because it's the last talk, so I know that not a lot of you won't want a workshop or go on your computers, just want to talk about something. So just go ahead and drop that in the chat. Hi, Shubham. Hi, Devendra. Great to hear you joining from all over India. That's really interesting. So some people are alive in the chat, so that's great to know. Oh, Olamide, if I'm pronouncing your name right. You're from South Africa. Hi. So I'm here to talk about the Microsoft Learn Student Ambassador Program and how you could be a part of it and what benefits it has to you. Okay. So I'll start my talk. So why you should be a part of the Student Ambassador Program? The first reason is the new Student Ambassador tagline, "Be a force for good," is what engages me the most. It's really attractive and why you should be a part of the community. So the first reason would be join the global community because the Student Ambassador Program is spread out in 85 countries and 38% of the program is from India. So you'll interact with lots of people from India and from abroad and learn a lot of new technologies, their cultures, what they're doing. So this is one of the most major reasons why you should be a part of the program. Then the next is make a difference. Since you're technologists, you're developers, you're designers, you have to be part of building the solution, be a part of improving the community, making the change. So making a difference is another reason why you should be part of this program. Then the next would be grow your skills by the resources provided by the program, by the mentors they have, and the sessions they keep on having, which we'll explore more about later. Then next would be empowering your communities. So now that you have the resources and the skills, you can help your community. Like many of the student ambassadors were here before me today and were helping you learn, go through workshops, doing labs, and all that. And then again, if you're doing all this, you naturally become a leader. You have those skills to be a leader, to help other people, to empower your community. So these are some reasons I should be joining the Microsoft Learn Student Ambassador Program. Then everyone is looking out for what are their benefits, what do they gain from this program. So these are some of the benefits that you get from the Student Ambassador Program. So when you enroll into the program, which I'll be talking about later, how you could enroll in it, you have to qualify to become an alpha member. And to become an alpha member, after you become an alpha member, you get some Azure credits, and these are monthly Azure credits. So you can use them, cross them, and explore all the technologies you have, and then again reimburse them. Then you get the Visual Studio voucher, and most of us do code either on Visual Studios, on Code Block, or something like that. But Visual Studio is one of the major used coding platforms. So getting the enterprise subscription is really helpful. Then you get the LinkedIn Premium also with that, and that could be used, if you know how to use that, it could be used very effectively. Then you get your own studentambassadors.com domain name where you could go and create your own portfolio and everything. And after you can host your first event, you transition on to the beta, where you again have first and the very sought out benefit of the program is the swag. So as soon as you qualify to beta, in a week or two, you have the swags shipped at your home, and we'll see a picture of the swags later. So that is one of the most major benefits. Then the next is the event support. So in-person events, you used to get all the subways and everything, but now they are providing mentors and speakers for the event. So you can contact them and get some mentors for the event. And again, Student Ambassador Summit is something which everyone looks forward to, and I'll talk about the India Summit in the next slide. And after you have been part of the program for a year and contributed enough, you qualify to the gold level, where you have direct engagement with the Microsoft employees, getting mentorship from them, being part of all the leadership programs, having opportunities to talk at talks being conducted by Microsoft itself and not just the student partners. So that's one of the benefits. Other benefits also include having leagues and connecting people. So this is a glance of my journey from the student ambassador program. So I gave my first talk when I enrolled in the program, which was last year in August, I guess. So that is where I started contributing to the program. I participated in a hackathon in my university where we got the third position and we had the most innovative solution. Then you can see here, my pointer visible. This is the beta swag that we got recently, and you must have seen this on Twitter or anywhere if you follow any of the student partners. So this is one of the most major attractions which people have. Then another is having access to teams and organizing events on it. And one thing I really love about Microsoft Teams is that it has, so if you are conducting an event, it will create a separate group for you where you are having a talk, you can chat, you can interact, and then you have this together mode where it actually feels like a real meetup. So it's really interesting. So I started by talking at the WomenCon Summit where, it was on IWD, International Women's Day, and where we talked about how Microsoft Student Partner Program helped women, be a leader, be engaging with people. Then I mentored two of the winning teams at Avadhya Hacks, and which was again in my university. Then I gave a talk at the Learn Day in my university. Then we were all the student partners from Delhi were invited to this summit, which was held last year, I think on 29th October on in MLH's Microsoft office. So there was Mike Swift, who is the founder of MLH, and he was also present at this meetup. And we had like a few hours, interacted with him, and it was just a very chill meetup. There were employees from Microsoft, there was Mike Swift, there were other people from MLH, and all of these were MSPs who were newly added to the program, and they were just engaging. I made really good connections at this meetup. Some of them are working with me right now. Some of them I conduct the hackathons with. Some of them I took other parts with. So it's really engaging. So if you have never attended a meetup, you should definitely go and attend one when these are back, or just attend virtually like at Microsoft Teams. So this is some of my journey. And if you have any questions, please feel free to drop them in the chat. Okay, so let's talk about the question which most of you have. What is the application process of the program? How are students selected, and how you could be a student ambassador? So all students are accepted quarterly. So if you apply now, you will be accepted in January. So every quarter we accept new students. So please go and apply as soon as possible, because the applications are, students are selected on rolling basis. So if you apply soon, you'll be selected sooner. So, and if you are not from a technical background, if you're of business, you're doing management, you can still apply, because Microsoft Student Ambassadors do support people from business background. We also have, learn paths for you, and you can apply and go into business analysis and all these fields. So do apply, feel free to apply. Again, a very common question while submitting the application is, do you need a background in tech? Do you need to have some knowledge in leadership? Do you need all these? So that's not true. So when you're applying, there are 3 sections where you can apply: either inspire, teach, or promote. So if you're inspired by any technology, you can either submit a text sample or a video sample, which should be less than 2 minutes, of explaining why you are inspired by that technology, or by that technical person, or by the developer, and what benefits it has to you, and all that. I would suggest that try to apply by the video format, because it's more engaging. And you can film the video anyway, either by your laptop camera or your phone camera. Just keep the audio clear, and that should be good. Then the next is the teach thing, where if you have ever taught anyone anything about technology that didn't know about, or had any sort of teaching experiences, again, try to capture that if possible, and if not, then make a video separately of how you taught him or her, what they were learning, and what they got out of it, and what were the benefits, and if they have any testimonials, include it in the video. So making a video would be beneficial, because you can include other materials in the video as well, either a presentation or pictures or any proof that you have of that. So try to make a video of it. And the next is promote. So if you are not from a technical background, or so you don't have a tech that inspires you, or you haven't taught anyone any technical topic, then you must have done some management work or been a part of any society in your university where you promoted the event, promoted a tech event, or remotely being a part of it. So go to the promote section and add your essay there or the video link there, and you can apply for the program. So here's the link that you can apply. These slides I think will be shared on the Con's GitHub later, so you can check this out, or you just, it's a very simple link. Even if you Google student ambassadors, this would be the first link that will show up. So either you can note it down or check out the GitHub link later. So it's studentambassadors.microsoft.com. So if you have any questions about the student ambassador program, please feel free to ask that in the chat. Okay, so the first question from Puneet is this ambassador program only for students? Yes, Puneet, this program is currently only for students. Even if you are a graduate student or undergrad or doing PhD, and or if you have plans to pursue PhD or any other studies in the near quarter, then you can apply for it. But yes, this program is currently open to students only. You can check out other Microsoft programs which are open for professionals. Next question. I am in first year and have good knowledge about C++ and Python. Is this the right time to apply for the student master program? Yes, I can't think I can say the name right. Sakalya, I guess. So yeah, Sakalya. So if you apply, do not even think that you'll get selected or not. Just apply and try doing it. And since you already have knowledge of C++ and Python, I think that should be good. Just include in your video what you learned and how you learned it, why you went for Python, why it inspired you. So just go for it, and I think that should be good enough. If you have any other questions, please drop them in the chat. Okay, Shubham has how can we also become student ambassadors for Microsoft Learn? I think I've answered that question. And yeah, so I'll move on then. If you have any questions, please feel free to drop them in the chat, and I'll answer it at the end of the presentation. So then next is exploring the Microsoft Learn platform. So some of you might have used the Learn platform already or in the sessions that were conducted by the speakers. So I'll just give you a little tour of the platform because I think it's very useful for any student who's out there. So by the way, this is the student ambassador website, and you can just go and apply now, and you will be redirected and asked a few questions about the application. Okay, so this is the this is the Learn platform, and you can just open docs.microsoft.com and go to Learn tab here, and you'll be redirected here. Why I picked this platform, or why I prefer this platform, because they have really curated content, and you can just go here and select whatever you're gonna do, maybe data analysis, business user, or whatever you're going to do. So let's go for students and see what learn paths they have. So like I think Sakalya just said that he has been learning C++ and Python. You can just go and enhance your learning here. What is Python? They have really good modules, I would say. I had this subject in my university called cloud computing, and to be honest, the content provided by the faculty or even by the seniors wasn't good enough. But there is a learn path here called Cloud Fundamentals, and it is really good. Like, you'll get all the cloud basics just right, and the way that they interact with you, even if it's just by text or little exercises that they do, it's really interesting. So you should definitely check out the Microsoft Learn platform. And there are other, this is one of the very popular modules, Introduction to Azure Fundamentals. So just go ahead and check this out. This is really good. And even if you're in data science, I think I have that one open. This Introduction to Azure Data Science Virtual Machine, this is again a very a good module that you could complete. This gives you basics of all the data science and sets up a virtual machine on your PC, and you don't need any Azure credits for it. So there is this thing called Sandbox. So you can use 10 Sandbox a day if you're using the Learn platform, and just go here, sign up, and start learning using Azure and Learn. So this was one of the best Learn paths that I've ever done for data science, because I didn't want to do that on my own PC. So setting up a virtual machine was really important. So just go ahead and check this out. Then the next resource that they have is the Learn TV. So some of the students, this was the feedback that we got later, that some of the students weren't able to connect as much with the slides or just the text. So again, student partners got to it and built a lot of Learn paths. So you can just go here and check all these out. There is just a deploying website in 14 minutes. I mean, what else could you ask for? Just deploying a website in 14 minutes. And so just go ahead and check this out. The next thing I wanted to talk about was Microsoft Azure, which was used in the workshop before my talk. So I think you're already familiar with the Microsoft Azure. If you are a student, you can just go to the Azure for Students, Google Azure for Students, and you'll be redirected to this link called azure.microsoft/free/students. And if you sign up using your university ID, you'll get a few credits, I think $150 worth of credits, and you can use them for learning. The better path to learn using Azure would be using Microsoft Learn to learn Azure, because you have sandboxes, so you are not using your credits anywhere. So just go to Learn and sign up there using your college email ID, and you can start learning Azure. Just something that I'd like to add, a lot of students come to me and ask why using Azure is important, or why you have to learn any cloud studies, or why it's getting popular. So a lot of companies have that, because no one is using traditional databases anymore. So a lot of companies have been migrating to cloud databases, and Azure being a product of Microsoft, and Microsoft being a reliable company, has become really popular and a major player in the cloud computing world. So you should learn Azure or AWS or any such, because if you will be working for a developing company, you'll have to work on cloud services. So Azure is being used on eBay, Boeing, BMW is also using Azure. So if that company resonates with you, that sounds interesting, you can learn Azure, and maybe that could increase your chances of getting into that company if you want that. But yeah, learning Azure is really fun, and with the Learn paths, it's really interesting. And I can even give you a demo of this, although there was a whole workshop on Azure, but I'll just show you the website. So you can, since I've signed in with Student Ambassador web ID, you can sign in with your college ID, and you'll get 100 credits to try Azure. And apart from that, if you are a student ambassador and are not using Azure, please try it. It's really worth the time. You can make chatbots very easily. There are tutorials on the Learn website. So go ahead and try this platform. It's really worth your time. You get 150 credits monthly. So that's worth something, right? So go ahead and try this. And if you have any questions regarding Azure or the application process, drop them in the chat, and I'd be happy to answer that. And yeah, that was a short talk. And if you have any questions regarding any of the platform, please drop them in the chat, and you can connect with me or ask me questions there. I'd be happy to review your application for the student ambassador program, or help you with any doubts on Azure or Microsoft Learn. So yeah, I can answer the questions now if you have any. Ismail is asking, is it any for professionals? Graduate students. Yeah. So if you go to the website of, go back to the link. If you go here, you can apply. If you are enrolled in any accredited university and are above 16 years, you can apply to the Student Ambassador program and help your community grow. So please go ahead and apply. Okay, do we have to fill all the 3 sections like Learn, Tech, Promote? No, man, you don't have to fill all the 3 sections, any one of them. So either you can go for Inspire, Tech, or Promote. So that's why I said, if you are not into tech or from a management background, you can just go ahead and apply to the promote section. You have to apply for any one of them, either inspire or tech or teach or promote. Okay. Ismail, the links will be shared on the KonfHub Tech's GitHub. Yeah, that's a good tip, KonfHub Tech. So there is a very student-friendly platform, which is GitHub, and the Student Developer Pack by GitHub is like a must-have. It has over 150 resources that you could exploit, use. Even so, the most common resource that I always get to hear is Canva Premium. So if you are into designing, because I'm a little more into designing, so I usually get like how do you have Canva Premium? So if you have a university ID, just go to the GitHub Student Developer Pack, add it there, and there is just one small question that they ask, which is how will you be using GitHub? And most of the devs or even designers use GitHub on daily basis. So just go and write what your reason for using GitHub is, and I think in a week or two you'll get confirmation for the Student Developer Pack. And keep checking. So if you open your GitHub profile, there'll be a pro tag under your name, and then you can use all the benefits from the Student Developer Pack. So do check that out. It has lots of benefits. It has educative.io's 3 months, I think, and interview cakes 3 weeks, I think. 3 weeks, premium features. So just go ahead and check that out. It is really beneficial. Okay. What Mayank is asking, what should I learn first, Azure, AWS, or Google Cloud? Or should I only learn one out of this? So Mayank, there are two ways to answer this question. The first would be if you have a dream company that you're aiming for and you want to get into it, just check which cloud it is using and just go and explore that cloud once. I would say most of these clouds, the tutorials at least on these clouds are pretty same. So even if you have knowledge of Azure or AWS or Google Cloud, you will be able to relate it to the other. It's pretty much like if you know C++, then you will understand Java and understand Python. So just do any one of them which you like. If you have a dream company, just Google which cloud it is using and just go for that. That could be a starting point. Or since Azure is student friendly and has lots of student benefits, go ahead and start using Azure. And we are all the MSPs here, all the MSLAs are here to help you. So I hope that answers your question, and I think that's about my talk. So if you have any other questions, feel free to ping me on Twitter or LinkedIn.
Thank you so much, Shivangi, for your presentation. And we will definitely share the links with our participants so that our participants can go and apply for it. And also, we see that there are so many students participating, so they can definitely get benefited out of it. And if they are students still, they can apply for the MLSA program.
Yeah.
So that was really insightful session of yours, Shivangi. And we hope we'll have you in our near future events as well to learn more about like how to get benefited from the community and how to contribute to it.
Yeah, sure. I'd be happy to help you anytime. Thank you for having me here. Thank you everyone for attending.
Thank you. Thanks a lot, Shivangi. Okay, guys, so that was Shubhangi. So with this, we have come to the end of to this conference. But yeah, so there is also some exciting things coming up. So we have the quiz for the second quiz today. So I'll just share my slide and show it to you. Okay. So guys, before starting off with the quiz, I would request you to go through the game rules. So these are the rules. There are 10 multiple questions and top 3 from the leaderboard will be considered as winners. Duplicate entries will be disqualified and the organized decision will be final. So here is the URL. The quiz is open and you can go and participate in it. Also, meanwhile, we'll be looking at our leaderboard. How is it going? So, okay, so we have already got 8 submissions. Just in case, guys, you are not able to find the URL, so it's already there in the comment box and also down the screen. And here's the link. It's just conf.me/oss-quiz2. So the leaderboard is this. We have 10 participants as of now. Okay, so we have 13 meters as of now. So folks, the quiz will be closed at 4:45 p.m. So you have just 6 more minutes. Those who have not yet participated in the quiz, they can do it now. Just in case you are not able to find the URL is here. It's con.me/oss-quiz2. The same is also mentioned in the comment box and also down the screen. We have 18 submissions as of now. Also, guys, duplicate submissions will be disqualified, so please refrain from it. The quiz will be stopped at sharp 4:45 p.m. We have already received 27 submissions. Folks, those who have not taken the quiz yet, please do it soon. We have 4 more minutes for the quiz. We have 30 submissions already. Okay, so we have just 3 more minutes for the quiz. We have just 2 more minutes for the quiz. So people, those who have not taken the quiz yet, please do it now. We have 46 submissions already. If there are anyone not able to find the quiz link is here. It's con.me/oss-quiz2. Also, we have just 1 more minute left for the quiz. Okay, guys, we have just come to the end and we are going to soon stop the quiz. We have already received 60 submissions. Okay, so here is the final result for quiz 2. Okay, so this was it. So before we go to the end, I would just go through the announcement of all the winners for our different challenges. So this is the winning leaderboard for quiz 1, which we had in the afternoon. So our first winner is Gauri Prasad Sharma. Second one is Ravi Shankar. Third is Sai. For quiz 2, which we just ran right now, the first winner is Paras Narang. Then we have Shubhendu Shubham. And third, we have Amit Kulkarni. So congratulations to all of you for winning the quiz for the event. Now we have, since most of you would remember that we were running daily challenge for open source software days, and these are the winners already listed on the website. So we have been running the daily challenge for 12 days, and these are the winners for respective days. For day 1, we have Madalam, then Dhruvam Pandey, and Gaurav Rohra. For day 2, we have Adesh Kataria, Hardik Dharma, and Gaurav. For day 3, we have Rishikesh, Ismail, Vinod Kumar. For day 4, we have Ajay Kumar, Yagna, and Ratana Kumar. For day 5, we have Bhavesh, Janani, T. Navnit. For day 6, we have Jagdish, Mohammed, Ashish. For day 7, we have Arya, Swaraj, and Sumant. For day 8, we have Yash, Murli, and Shushma. For day 9, we have Amit, Aman, and Bhuvaneshwar. For day 10, we have Ajay, Rishabh, and Harsh. For day 11, we have Akash, Beneta, Muskan. And for day 12, we have Jose, Kishan, Avishkar. So these are the winners for our daily challenge. So congratulations to all of you for winning. Next, we have the referral contest. So a lot of participants helped us in encouraging people for the conference and reaching to a wider audience. So these are the winners. So the top 15 of the leaderboard will be considered as winners. So the top 5 will receive rupees 2000 cash, and rest of the 10 will receive rupees 1000 cash prize. So here is the list. First is Vinod Kumar, then Amitesh, Deepak, Hardik, Gerald, Ronak, Saurav, Abhay, Porkalai, Ashish Anand, Namrata, Shirish, Bhavesh, Samira, and Amit. So these are the winners for our referral contest. So congratulations to all. So now, since we have already announced all the winners, so we would request all the winners to reach out to us by email. So our email address is there in the comment box. So we'll be commenting the email address, which is reachers@konfhub.com. So you can reach out to us, and we'll be taking the process after that. Okay, guys. So also we have the feedback form. Uh, it is already mentioned in the description. So requesting all of you to please submit the feedback form and let us know how did you enjoy the conference. And also, if you want the attendance certificate, please mention in the feedback form. So there is an option for receiving attendance certificate. Also, we would request all of you to subscribe to KonfHub Tech YouTube channel so that you get notified for upcoming technical events being hosted on the channel. For regular updates, you can follow KonfHub YouTube and KonfHub Twitter. Okay, so now I will show you the anyway, the conference is over, but we still have one more challenge for all of you. So it's Azure Dev Challenge. So what you need to do is just complete one of these learning paths mentioned here. So we have 3 different learning paths. You can complete any of these, and then you need to share your Microsoft Learn profile and achievement badge with hashtag OSS Days on Twitter. And also you need to subscribe to Microsoft.source newsletter. So what is this Microsoft.source newsletter? It is nothing but a regular digest of all technical relevant content, events, and trainings happening here and there. So if you sign up to this newsletter, you will get notified for all the technical events happening, and you will also get regular digest of the relevant technical content. So with this, we would like to thank all the community partners who have helped us in reaching more audience and making this event grand. So we had 27 community partners. I would name all of them. So we had AI and ML Group, Bangalore CNCF, Cloud Native Bangalore, Co-Learning Lounge, CoderPlex, CyberSpy Quince, DevScript, Docker Bangalore, .NET Bangalore, Elastic, Geek Community, GulsScript, Hypertrace, Indian Startups, InfoSec Girls, Java Meter Bangalore, Mozilla India, Open Community, PyLidis Bangalore, PyLidis Chennai, Python Group, Redis Labs, Script Foundation, Soda Foundation, Technology, Cafe Bengaluru. So thanks to all these community partners for helping us in reaching more audience. Apart from the community partners, we also had Edureka as learning and streaming partner. So we are really thankful to have Edureka as helping us reach more audience and streaming the whole conference to their platform. Also, a big round of applause and thanks to Microsoft Azure for sponsoring the event and helping us with the learning resources and technical contents which was provided during the conference. Also, at last, I would request all of you if you could make a social media post on Twitter along with hashtag OSS days and tagging KonfHub and letting us know how did you enjoy the conference. This would really help us and encourage us for the upcoming events. So with this, I think I'm done. So thank you all. And also we have our workshop happening tomorrow. So I would request all of you to register for the workshop. The workshop details are here on the website. So tomorrow we have Vivek Sridhar from Microsoft who will be taking a workshop session on Kubernetes 101, followed by Karan from GitHub, who will be taking session on CI/CD with GitHub Actions and Kubernetes. So if you have not registered yet, I would request you to register for the conference here on the website. So if you register for the event, then you'll be getting notification for the event tomorrow along with the live URL. Also, those who are asking for the learning resources and the speaker slide deck. So all these details will be shared via post-event mailer. So those who have registered for the event will be receiving a post-event mailer, which will have all the learning resources, speaker slide deck, and also the recorded session link. So also, since a lot of people are asking where do they need to mail to receive the prize money for the several contests. So we are just sharing the email address in the comment box so that you can email us. Yeah, so the email address has been shared in the comment box. So all the winners can reach out to us over email and let us know so that we can take the process further. So with this, I'd like to thank all of you for joining today for the conference and and to celebrate the love for open source. With this, we'll be taking a break. So thank you and looking forward to have you all in our future conferences as well. So thank you all.